I welcome you all to our very first class for the physics students of 2026, measurements and dimensions of physical quantities. Okay, now you all know that we always first look at what the syllabus may want us to cover as far as the topic is concerned. Before this class, I already warned you about or told you about the course content of physics, and you know that this is the very first topic. Then we go to statics and then enter kinematics. Statics has stuff of resolution and uh, components of a force. Then we have moments and couples. Then kinematics, that's where we introduce motion. Linear, vertical motion under gravity, that is free fall, then projectile motion. And all those, the mathematical physics was already covered. I don't know how far people have gone as far as those are concerned. So for today, I want us to cover this and complete. So we are not going to leave this class unless we have the final assessment on dimensions and measurements. So that the next time we are to meet, we cover something else in line with physics, of course. So, as usual, whoever gave us the opening prayer, thank you so much. So as usual, I will first give you a brief introduction about SSA, and then we shall have the introduction to the topic. So with me, of course, I have the syllabus book that is going to guide us on which content really cover. You can see Senior 5 Term 1, it is strictly and strictly measurements and dimensions first. Then topic 2, we can move to statics, where we look at the forces and then we go into moments and couples. Okay. Then I also came with our book, of course. We always use our notes strictly prepared by SSA tutors. And I told you that we use these for strictly lessons and nothing else. So very first, it is the same, we usually covers you up in science and math. Dr. Polo, you can call me Paul Tutor. You can just call me Doctor. It's also okay and enough for me. Hope you are together. Now, of course, you know that I tutor math and science at SSA Science Scholars Academy, Uganda. And our vision is to create, so whoever is here should try their level best to become competent. Because that's what we endeavor to. That's our endeavor, to create scholars that are competent enough. So our services are only and only 3, nothing else until further notice. So we handle all the coaching programs. Of course, when you come back at school and you have issues with certain topics, when you come back, we hope you revise those topics and also cover for your work of the next term. The day scholars, we do homeschooling for you. Even if you're not a day scholar, but you're going to solely be at home, maybe because of fees issues, because you have maybe a disease. People have issues, especially the students who usually handle their diseased. So we handle them very well at home, at their own convenience. So that's the homeschooling program. It's just like a normal schooling program, provided with everything, the notes, assessment, and so on and so forth. Then those with personal issues and really want one-on-one sessions, I told you those are free, provided it's counseling, consultation, advice. But if it's outside that, it's at a fee. Okay. So the subjects are basically for the major science subjects: physics, biology, chemistry, and math. For the other science subjects, we provide you with the best material. But these ones, on top of the material, we guide you under video classes. The live ones, just like this very one, they'll come via Zoom. The rest, in case one misses them, these are recorded. So we upload them on our app. And those we may need to give to students as free classes. We either upload them on YouTube or put them on Google Drive. But even Google Drive and YouTube both can have private classes. That's why you don't find everything there. Is it okay? So whatever you don't see there is there, but we have just decided not to put it. Then the summaries notes, I told you, those ones, we just use them here. But we are still thinking twice about how we can give you the whole library for your combination, especially the science combinations. Okay? We strictly concentrate at A level. You can just take a screenshot. I told you to get in touch. You all have my number. 0753 279592. And those who are part of the channel, you know that in case I delay to respond and it's running out of time, you simply contact the support assistants. They can help you with that. So thank you for listening and thank you for giving me the chance to talk about everything. So, very first, the syllabus book. What are we really supposed to cover under physical quantities? And before I proceed, before I even go through all this, do I have anyone who really wants to be blessed? Anyone who wants to bless our class? You introduce the topic with me. Who can help me define only physical quantity or physical quantities? Who can help me define that? So we are simply looking at measurements and dimensions of those quantities. So who can tell me what are those physical quantities, if I may ask? So I told you our video classes like physics, senior 6 work was covered. Yes. So the moment you're done with senior 5 work, you just switch. You go and cover senior 6 work. Even when the senior 6 topics are covered in Form 5 in your school, you just be ready, then you come and cover with us, period. The always are available year in, year out, 24/7. Anytime you need them, whether at home, whether at school, under our guidance, you access them, you like it or not. So who is that student that is going to introduce the topic with me? You define physical quantities. For me, I assist in measurements and dimensions. Yeah, that means we shall have covered the lesson together. Who can just tell us the meaning? Don't define, okay, the meaning of physical quantities. Who can tell us? Who can tell us? Who can tell us? No physics student is going to give it a try. You people, when they ask you something physical is something you can touch. You understand? It is something you can touch. In physics, it is mathematics. You cannot tell us that we really need to touch something here. But provided something can be expressed or can be measured, you understand? Something that is physically having quantity, something we can measure and express it in terms of a number. You measure the length of a road and you say that now this road is 20 kilometers. You understand? So its length is now a physical quantity because you could measure it and express it with a number. And in some of the cases with a unit, the mere fact that you've said kilometers. So whatever we are going to be looking at are things you can measure, are things you can give a number, and then things you can give a unit once in a while. Is it okay? You measure your body temperature. The mere fact that you end up saying my body temperature is 35, you've given it a value after measuring it. And then you add on degrees Celsius, you attach it with a unit. That makes it a perfect what? Physical quantity. 1, you've measured it. 2, you've expressed it with a number. Lastly, you've added a unit. Is it okay? Hope that is enough introduction. Now, what are we really going to cover today? We are going to brainstorm first and foremost. So the topic is divided into 2 sections and we are covering both of them in this very class. The first one is going to look at measurement of a variety of physical quantities with minimal errors. We are going to see errors, everything. Then the second one, which is the major target, is handling dimensions strictly. And then we are going to see what we really need to cover under dimensions, what we really need to cover under what? Measurements. So I'm not going to waste time writing down the lesson targets. After all, we are completing topic 1 in this very class. So we're going to just cover everything at once. But you should have a lot of knowledge from O-level physics. There are some things that are just obvious and I'm also just mentioning that I believe this is obvious. And then I proceed. Okay? So what are those things we are going to look at in this class? We are going to first and foremost brainstorm what fundamental and derived physical quantities are. We just review the concepts to do with scientific notation and significant figures, because in the end we shall need to talk about accuracy, so they are very key. Then we are going to see how measurements of a variety of physical quantities is done with appropriate instruments and stating their level of accuracies. So the instruments we should really emphasize: vernier calipers, we have micrometer, screw gauges, and then the digital measuring instruments. There are so many. Just here we are going to give a hint, but this is more of practical physics, but I'm going to give you the theoretical part that you may need in the practical. Then we are going to talk about the sources of errors. These are things that happen, or things that have even ever happened to you when you're in a practical. Errors, you get? And then we are going to see how best they can be minimized. There is no actually physics here, it is just English and literature. But then the physics is going to come in here when we start dimensions. Okay? I think that is okay now. So the lesson targets are clear. Okay, now our notes is going to be our workbook. So I've told you that the lesson targets are clear from our student-friendly syllabus book. Yeah. The moment we tick whatever is there, we are good to go. Okay? Now, very fast. Most of these things you've heard of them. You've heard of fundamental, you've heard of derived, you've heard a lot of things. So we are going to move. Okay. So it is the very first topic or chapter 1, and that is the name. So we are going to begin with measurements first, then dimensions are going to come in. Yeah. Okay. So first and foremost, physical quantities. So they are saying physical quantities are divided into two groups. You quote that. The fundamental ones and then the derived. So the fundamental, I told you they can call them basic quantities. Yeah, some people can call them basic quantities. So they are basic, they are fundamental, like they are even on their own. They don't depend on anyone. That's why we simply say that they are quantities that cannot be expressed in terms of other quantities using any mathematical equation. For them, they are on their own. The mere fact we call them fundamental. They are what they think they are. They don't need anyone in their life. So you cannot express them in terms of other quantities using any math. They are just like that. And the major three, there are others, but the major three at your level that we concentrate on, it is mass, length and time. Mass, length and time. Hope you are together. So what you're seeing in what you're seeing in the brackets, you're going to see what they mean in the end. But meanwhile, just have them as mass, length, and time. Then the derived quantities. So these two are forms of physical quantities. So physical divided into fundamental and derived. So as we hear the word derived, it simply means they have been derived from somewhere. The mere fact they have been derived from somewhere, that means we can write them in terms of that very thing. So they are derived from fundamental quantities. And the mere fact that they are derived from physical quantities, we can write them in terms of physical quantities. Are we together? So they are derived from fundamental ones. That means we can express them, we can write them in terms of the what? The fundamental physical quantities. Of course, there are three. They're even repeating them here: mass, length, and what? And time. So the other name for the derived quantities, they can also be called dimensional quantities. Yeah? I don't know whether you people are good at English, but when you go to the internet and ask it the meaning of the word dimension, because it really disturbs so many people. They look at it as something that doesn't relate to whatever we say under it, but simply because people don't make research. But dimension is just related to the word, as we hear the word derived. Under what dimensions is something really existing. So dimensions are like a makeup of something. So when you go to English, it will still rotate around there. So the mere fact that they are derived quantities and if at all they ask you, how do they come about? Under what dimensions? Under dimensions of fundamental quantities, and we are going to see that also. And we are going to see under dimensions as to why these ones are even called dimension ones. 0K. Don't want to waste a lot of time there. So they are telling you that derived quantities are those physical quantities which can be obtained by combining fundamental quantities mathematically. So they are derived from fundamental ones mathematically, or you can say they can be expressed in terms of the fundamental ones. Like examples are so many, that's why we have there etc. But we just chose these. Acceleration, speed, power, force, momentum, energy, work done. There are so many, but we just picked a few. Okay? Now, there are those physical quantities. It's not that all of them really come from mass, length, and time. There are others. There are others that don't really relate to mass, length, and time. And there are so many also. We have relative density, 0K. We have logarithms. We have trig ratios. We have mechanical advantage. We have pure numbers. Remember when I told you that physical quantities, when you put there a unit, it really makes sense. So when you look at whatever is here, these things that you're seeing here don't have units. You get? So the mere fact they lack units, that's one of the reasons that's why we call them dimensionless or simply non-dimensional. Because now we expect any dimension to have at least units. But then they are dimensionless simply because you can look for a way of how to relate logarithms to mass, refractive index to mass, relative density to mass, and you can't. You can relate density to mass, but not relative density. You all know the formula of mechanical advantage. It's a ratio of similar quantities. By similar, I mean they share a unit, load and effort. 0K. So anything that cannot relate to mass, length, and time, we consider them as dimensionless or non-dimensional quantities because they are just numbers, they are just constants. So I also add for you here because we shall need it when we start dealing with numbers that have dimensions, that also constants. Constants are also dimensionless. They usually have letter K, hope you are aware. Most constants in science, they have that letter small k or capital K, whatever. So constants are also dimensionless. Because now if I give you a number like 20, can you really relate it to mass, length, or time? You're not even sure. So it's dimensionless. Okay? Just like you can even see here, the word pure numbers. Hope that is fine. In case you're left behind, you be very fast and comment. Okay, now back to the syllabus. Brainstorming those two, I think we are done. So I don't think anyone has been left behind. So now let's go to B, reviewing the concepts of scientific notation and significant figures. Okay. Now, scientific notation, you can simply use your calculator. Someone may be like, why are we looking at that? Is it really necessary? All you need here to understand is the cheat code because not every time the calculator will provide that. And even if it does, do you have the knowledge behind or you just copy? You need to be a competent science student. Yeah? Okay. Now they are telling you that scientific notations only and only expresses numbers in this format. A times 10 power n. So they are telling you that this a that we have is supposed to be between 1 and 10. Are we together? Even 10 is risky. But why we are saying 10? Because we have something like, okay, the mere fact that they are saying between 1 and the minimum is 9 point, okay, the maximum is 9.9. It cannot be 10. If you have a chance of 10, you take it as 1. But I will be briefing here as we calculate a lot. Those who have visited the drive and you've looked at the calculations of progressive and stationary waves, you know how we write answers in physics. If standard form exists, it's better. So scientific notation is now synonymous to what we call standard form. So the moment you apply scientific notations, you're writing something in a form we call the standard form. Then also this n is supposed to be an integer. An integer simply means not a fraction. Not a fraction. Not a fraction. But by integer, we mean it can be a positive, it can be a negative. So if I told you have here any answer and this power is a fraction, that is not perfect standard form. If this one is not 1 and between 9.9, then it's also not perfect standard form. Hope you understand. Okay, now we put here some 3 numbers, of course not many. For these ones, I'm going to be a bit fast because I believe they are cheap things. If you have a number like 5,000, this is the better answer. You get? You simply move like this. You move, okay, the number is 5,000, like that. So this is where the number ends here. So you're supposed to move 1, 2, 3. So it becomes 5.0 or just 5. 0k. Are we together? Then you be like times, of course, 10. Now you have moved 3 steps. And you've moved 3 steps to the left. When you move 3 steps to the left, this power is supposed to be a positive. But you look at this. The value is 0.002. How are you going to move? You're going to move like 1, 2, then 3. Are you seeing? So the point will be shifted there. So we'll have something like 2 times, of course, 10. Now, yes, you've moved 3 steps, but to the right. And when you move to the right, negative. I know that people know that. So that cheap thing. Now this one. This. And these values are there in physics. Those values of speed of light in air, speed of light in a vacuum. You always see that they try their level best to have it in standard form where they can. When you look at a standard paper of physics at the front, most values there are in standard form. So it is key. It is key for a physics student to be understanding how standard form is written. So when you look at this 3200 and then other zeros. So the value is ending here. So how do you move? 1, 2, 3, 4, 5, and 6. So the point will come here. So you have 3.2 times 10. You moved 6 steps to the left. So this integer is supposed to be positive. Even if you don't recall those things of moving to the left, you put positive. Ask yourself, which number can I really put here? Is it negative or positive 6? Which number really takes you back to the 3.2 million? Of course, it can't be a negative. It has to be a positive power to take you back to the million. You get? When you're dealing with such a value, and you know that you've moved the 3 steps, and then you put here 3, ask yourself, if I don't put a negative, this one is taking me to 2000. You understand? But then the original value was what? 0.002. So that means it's supposed to be a what? Negative. So as you're moving to the right, negative. As you're moving to the left, the power or the integer is supposed to be that. Then you have all realized that the value we are having here, this one, is always less than what? Less than 10 and greater than 1. I don't know if I have anyone with questions to do with the scientific form or standard notation whatsoever. Okay, I will proceed. So we are saying moving the decimal to the left, positive power. Moving it to the right, negative power. Is that really hard? right now, right negative, right now. Yeah. Okay. Significant figures. So these ones just show how precise, how accurate a measurement is. They are also not very hard, and I believe you've heard of significant figures. So for you to understand, they're also part of the syllabus. So whatever the syllabus said, we should say it. Though you need it in practical, but even as you're doing your calculations, if they need that accuracy, that precision, you're supposed to follow instructions. Is it okay? Now, what are they saying? They are saying that all non-zero digits are significant. You get, if you have something like 1, 3, 5, 4, oh, these values are none of them is a zero. So these are what we call non-zero digits. Of course, from 1 to what? 1 to 9. In any combination, they are significant. So when they give you such a value, 3 significant figures, such a value, significant. Someone may be like, what if I have a 0 in the middle like this? We are going to see this also. But they are first telling you that at least when you're counting, consider this, because those ones are non-zero. So at least first secure the 3, then ask yourself, how do I deal with this 0? Which we are going to see below. But if you have only them, 9, 8, when you have almost all of them, 1, 4, all these ones are non-zero. Okay, there is no 0 there. So you just count 1, 2, 3, 4, 5, 6, 7. So those are 7 significant what? Figures. Then they are saying zeros between digits are significant. So provided any 0 comes and that 0 is between non-zero digits, to make it better, I'll say between non-zero digits. You get? For example, you have 5, 4, 0, 0, 7, 8, 9. You first secure, these are 2, these are 3, those are 5 so far. But then these 2 zeros are between the non-zero, so you consider them. And then you come up with 7 significant what? Figures. Even here, there are 4. Hope that is clear. What are they saying? They are saying leading zeros are non-significant. Leading zeros, what does that mean? They mean zeros before non-zeros. Zeros before non-zero digits. All of them, because they are now leading the non-zero digits, they are non-significant. So when you look at such a number, all these ones are 3 zeros and all of them are coming before the non-zero digits 4 and 5. So the significant ones are only 2, the last 2 non-zeros. So if you have something like 0.05078, someone tell me, how many significant figures do we have there? Tell me in the chat, how many significant figures are there? Tell me in the chat, how many significant figures do we have there? 4, exactly. So we are having these 2 leading zeros. Why are they called leading zeros? They are before 5, which is non-zero. So these ones are out. But then this 0 is between 5 and 7. 5 and 7 are non-zero. So that 0 in between becomes significant. So they are strictly and strictly how many? For SF. See? Very cheap. They are saying trailing zeros. Significant. Trailing, usually when they are coming, okay, all zeros that come after. So by trailing, provided they are coming after the non-zero, they are significant. So even if you have 5, now this is what usually confuses people. How many significant figures are here? Is it only 1 or there are 6? How many are there? Is it only 1 or there are 6? You see, that's what usually confuses people. The first 2 people have said only 1, and there are people who are saying 1. You're wrong, there are 6. Provided, so by trailing, we mean zeros after non-zero. Zeros after non-zero. They are what? Significant. So these are zeros, they are 5, but they are coming after a non-zero digit. So that makes them 6 significant figures. Hope you correct that also. Not 1. Now the one significant figure is this. Are you seeing this? Now these are what they call leading zeros. There are zeros and there are too many and they are leading. You see? That's why in the end they tell you that it's better for you to write such. It's better for you to write such in standard form. How? 1, 2, 3, 4, 5, 6. So it becomes 5 or 5.0 exponent. You move the 6 steps. When you just put 6 there, you may end up getting 5 million. Sorry. So to make sure that you go back to this value, put here what? Negative. Or you remember the rule of right now. Right now simply meaning as you move to the right, the integer should be a what? Negative. So negative 6. So even when they tell you to round off such a number, and they tell you round it off to 3 significant figures, you simply just have this. 4 is significant, 5 is significant. This should be the third, but because of this 7, 6 becomes 7. Here, round off to 3 significant figures. You must stop at a 4, but because of that one, 4 is kept as 4, no change. Now, when you reach such a number, 3 significant figures, you realize you cannot stop at a 9 because this 5 should make a 9 a 10. Even the other 9 is made a 10, even the other 9. So you come out with something like this. So are you aware that these ones are 3 significant figures? Because all the zeros we have are coming after a non-zero. So they are significant. Hope I've not left anyone behind concerning that. Okay? So we are really moving. You see, we are now on measurement or measuring physical quantities. So I'll go back to the syllabus and check. So even this one, I'll put a tick. You still have a long way to go. So stay on, stay quiet, we move. So what we are going to really look at under this measurement, this is where your research actually falls. But don't worry, it's not too much. It's not too much. It's not too much. Now, we are going to look at vernier calipers. We have rulers, we have micrometer screw gauges, we have even digital instruments. Now, your research is to go to YouTube, use the internet, find out how they work. What I'm going to emphasize or what I'm going to concentrate on is how they look like, what they measure, and maybe their levels of accuracies. Then I'll talk about the errors and how we can minimize them. Then your research as the student is to make sure you go and look at how the different instruments. Okay, so your research as a physics student. Okay, research. You're supposed to watch YouTube videos, supposed to watch YouTube videos on how the different instruments work. Yeah, that is the research question. So please, you do the needful. Which instruments? We have them. Yeah. So someone will be like, which instruments? The ones in the notes. The ones in the notes, which notes we are going through. So every instrument we come across, you note. Every instrument we come across, you note. Is it okay? Now we go. So measuring length, we usually use a ruler. We have a vernier caliper. We have the micrometer screw gauge. So the accuracy is this. Someone may be like, what do you really mean by accuracy? What do you mean by accuracy? You people, let me ask. If you very well know that the true length, for example, you people buy, which thing do you usually buy as a student and it has length? I want to use something that you're used to, but what can I use? You tell me in the chat before I choose myself. What do you usually buy and it has length as a student? You tell me anything, not a ruler. The ruler is now the instrument. I want you to tell me anything you buy, and in the order details they attach its length. Okay, someone has talked of a belt, but you people, calculator, people are saying phone, mattress. Okay, mattress. Someone has talked of a mattress. Even clothes, they usually measure your waist and so on. But a mattress, I think it's better. So you know that most schools in Uganda, the beds are 3 by 6. I think that is it. So 3 by 6, they have measured. Who can tell me? When they say 3 by 6, what do they mean? 3 centimeters, 3 inches, or 3 meters? Let me see. You are physics students. Those are one of the jobs of engineers to make beds. So when they say 3 by 6, what's the unit? Centimeters, millimeters, kilometers, meters. What is it? You see people saying inches. Are you sure they are inches? Are you sure they are inches? You people are not serious. Hey. Someone has said it feet. They are feet. They are feet. So your role as a physics student, you should know how is a feet. Okay. Okay, how is the unit of feet related to inches? Hey, you people, you're not serious. I'm really disappointed in many of you because I had not mentioned the unit. People wanted now to use guesswork and look at all the units I've given them to choose which one really works. Okay, that was just a by the way. I wanted to tell you the point of accuracy so that you even understand the errors. So, those things you hear that a bed is 3 by 6, the bed is 4 by 6, 5 by 6, 6 by 6. These are feet. You check the internet. You've studied at a very good era where the internet is very okay. You see, feet, feet, feet. So when you later on bring your tape measure or any instrument that really measures feet, and okay, you know now the true length is maybe 3 feet, of course, for the side where you put the head. But then you bring any other instrument. So I'm going to put here measured length. When you bought the mattress, they told you it is supposed to go on a bed of 3 by 6. So you expect 3 feet. But then you bring the instrument and it ends up measuring 2.9 feet. Or it can measure maybe 3.1 feet. It happens. It happens so much. So that's why you're seeing something like 1 or minus 0.1 for the accuracy. So that means by 2.9, that means the instrument was less accurate. By 3.1, that means the instrument was more than accurate. You will do this in project work. That's why I'm briefing you. Whatever I'm doing now, you need it in practicals and project work. So by 3.1 feet, it was more than accurate. But 2.9, we already say less accurate. But you know that the true value is what? 3 feet. That means accuracy is so important. It is simply a measure of how close the measured value is to the true value. So here we say that 2.9 is the measured value and it is less than the true value by 0.1. You get? So that measurement of how close the measured value is from the true value is what they call accuracy. Then 3.1, we say that it is greater than the true value by 0.1. So 0.1 is how accurate. You understand? That's just English. So let me hope you're not confused by these values. So you're supposed now to make more research about that. But I've told you the gist of the lesson is you living when you can handle dimensions, but also have this knowledge. So when you go to YouTube, put in, I want to watch a video of how a vernier caliper works, so that you understand what external diameter means and internal diameter. You people, you've heard of pipes. You've heard of pipes, your students. I think what you know most, they are test tubes. So when you look at these things, they have that inside part. That inside part cannot have the same diameter as the what? The outside. Because of the thickness of that glass that makes the test tube, or that glass that, or sorry, the rubber that makes the pipe. Hope we are together. So, internal and external diameter are different. We have depth. Who doesn't know depth? It is a form of height. So these are the parts of a vernier caliper. Why I added this, that as you're making research, you make sure you look at the main scale, vernier scale, the jaws, and the depth rod. The moment you see that, then you'll be like, yeah, this is now the right vernier caliper. Even if you go to the app I told you the app for images is called Pinterest. It's even having some videos. So make sure you have this app in your phone as a student, so that for such things, you make research. It will make your education and learning interactive and nice. Look for the jaws depth. You even watch how it works. But that is yours. Though we had to watch those videos in this class, but it is your research. We never leave class with research. Then the micrometer screw gauge, that's what it measures. Thickness, diameter of wires, small objects. That's why it's even having, okay, it is even more accurate than the rest, because it is in position to even measure very small what? Objects. Its parts are those: the anvil, the spindle, the sleeve scale, the thimble scale. You see? But the moment when, imagine being in project work and you should use a micrometer screw gauge, even when you reach campus, engineering, how can you leave certain courses without dealing with this? Civil engineers, you need all this. So it is very key. That's why I'm giving it to you as research. That you may not need it to pass an exam at A level, but you will need it in project work. You may need it in practical, even at higher levels of education. Okay? Then digital measuring instruments, they are also part. That's why the syllabus even fixed in a topic under light, I think it was under optics, called digital electronics. So I think maybe 10 to 20 years from now, physics will be purely digital, because it's the subject that is in line with technology. So examples, we have a digital thermometer, digital stopwatch, digital balance. We have digital weighing scales. Those ones that they even use in chemistry practical for weighing. I don't know if you have looked at them. Yeah, it is just like a simple plate with values that are digital. So you put there your sample that you want to measure. Maybe they told you measure 1.5 grams. You get? So I'm going to use digital instruments to explain to you what they call the zero error, because the syllabus also wants you to identify the sources of errors, as you can see, and then how they can be what? Minimized. You see? So I think I'll use digital instruments to explain errors. I think they'll bring out everything better. Okay? We go. Now, what are the advantages of this digital stuff? It is easy to read, and they are very accurate, other than these other ones. They are very accurate. Anything to do with digital. Leave alone the analog stuff that can even be affected by vibrations. But digital stuff is even built with systems, inbuilt systems that are not really affected, or that cancel effects of vibrations. There is no parallax error. Parallax is to do with vision, of course. I know as a physics student, it's not the first time for you to see the word parallax. Parallax in measurements is looking at something at an angle. We shall see that when you're using a ruler, a meter rule, and you try to look at length of anything at an angle, you may end up getting a slightly wrong value. So that's what we call the parallax errors. When you try to look at something at an angle, yet you're supposed to look at it directly for you to get the right value. That's why they call parallax. These things weren't there in the old curricula, but I've liked it that they wanted you to be briefed on this. Things that help you in the future. You see? Now these are sources of errors. I've told you I'm going to use digital instruments. Maybe people can get it well. Now we have what we call systematic errors. And they are telling you these ones occur in the same direction every time, in most of the cases. Now there is what they call the zero error. Even if I don't use the digital weighing scale, I don't know, you people are Gen Zs, there are some of the gigs you may not know. But for us who are there for some good time, who have been there for some good time, students used to, okay, not students, but our village mates used to collect what they call scrap. Then they go and sell to get money. I remember one of my friends used to tell me that a kilogram used to go for, I think, 1,000. I think 1,000 only. Had a friend who was trying to convince me to sell some of my parents' stuff that were metallic. But that was years back, I can't recall. I think it was early 2000. Back then. So I don't know if people know that scale they usually use. I don't know in which other places it exists. I also recall those places where they sell chicken feed. Yeah, food for those birds. There are always those weighing scales. Have you tried to see those people before they weigh? They try to put it down. Okay, they force it to go back to zero. Do you know that? Either, okay, wholesale shops, those things are there. Those big buildings that deal with selling chicken feed. Okay, poultry feeds, if I can say. Then also, which other place? I think you know the places. Even if it's not that way, okay, any other weighing scale. Have you ever realized that these people want to first make sure it's back to zero, then they can measure? Because if it starts past zero or after zero, you're going to get a wrong value. So that error that is made when the measurement started before zero or after zero and not exactly as zero, it's what they call the zero error. Is it okay? It happens with digital weighing scales. That's why they always tell you to reset it back to zero. When you reset, you can now measure, not letting it to start in negatives or in values past a zero. So that's what they call the zero error. So always reset the digital instrument before measurements can be done. So you may be using a ruler that is broken. Most of you have faced that. In school, not even in practical. You know very well your ruler does not begin from a zero. Maybe it begins from 0.5. So everything you measure, you're supposed to subtract 0.5 for you to get the actual value. You get? So, or you may be having wrong calibrations. Most of you have realized that. Use your ruler. Your physics teacher tells you that ruler is not good. Those calibrations are not good. That's why in some organized schools, they even tell you that this is the type of ruler you should bring because they know others have issues with what? Calibrations. I think that's not hard. So for you to minimize those errors, make sure you correct the zero error, have well calibrated instruments, use standard ones. This is just English. It was there. This is information from the book called Physics for Today and Tomorrow. All work, imagine. You see? There are these random errors. Most of you have dealt with the swinging pendulum. I don't know if people have looked at it. A string, at the end of the string, you attach a pendulum bob, or you attach a bob. Then you start. You suspend it and then release it, and it starts to oscillate on its own. You realize that you're supposed to release it as you immediately start. the stop clock. That is something that usually disturbs students, like starting the stop clock at the same time when you release the bulb. That's what they call reaction time. Eh, so the reaction time is always very hard. So those errors are just random errors. They just happen. You don't plan them. You're not even sure that they're even perfect. Most of you know you've dealt with pendulum bulbs. The moment wind comes, that is an environmental change. It can give the pendulum bulb a weird oscillation that is going to affect the periodic time you're trying to look for. Do you see that all these ones are obvious things? But you need to be aware of them. As people who will train others, as people will ever go for training. So the solution is always to take as many readings as you can, and then later on you calculate for average. And I think you've tried that before. But those are just random errors. I told you about the parallax errors. In physics for done tomorrow, they put it under personal errors. It was just a simple statement. When you view anything from an angle from a side, you may not see the exact value. And to avoid such an error, look into the instrument directly above the scale. Not looking at the scale at an angle, you're going to get a slightly wrong value. Instead of 9.6, you will instead read 9.4. And most of you have realized that error, that you have here a value of 9, here you have 10. Now you have here a very long line, then you have 9.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then the other one. So this value usually gives you part time. This one and this one. Just make a mistake and try to view from an angle a side. You may end up calling this one 9.4, you may end up calling this one 9.6. And you also don't know how, but you wrote it. So these are just normal errors you encounter as you. So the reduction, be careful, repeat measurements, really confirm. So accuracy, I told you it's how close. What you've measured, how close is it to the true one? If the true value is 10, you measure 9.9. That means this value is less than the true one by 0.1. So this is the what? The how far or the how close. See? And by absolute error, absolute means we treat everything as a positive. So we say that, but we shall see this under error analysis. All physics students are supposed to do math, you like it or not. At least if you do PCB, do submath. And even in submath, errors are told. So you will come across that term of absolute error. But I'll give you these notes, you keep on reading to perfect. I really wanted to use all this for only 40 minutes. I don't know. Are we already 40 minutes past the lesson time ever since we started? Because now we have ended. We are entering now into the what? The dimension. I don't know if I've tried to keep time. So accuracy depends on significant figures, decimal places, a lot of things. That's why they tell you, let me ask people, of these two values, this is 4.5 and this is 5.5. Which one is more accurate? The first value or the second value? Which one is more accurate? Which one is more accurate? Let me see anyone who is going to give me a correct answer. Most of you are saying the first, others are saying the second. But the best answer is that it depends on the instrument. Those things of better. In chemistry, math, and biology, the best answer is 5.45. But in physics, it depends on the instrument. You don't just get excited just like that. We don't do that this side. So these are the methods of minimizing errors, and this is just a summary. Use accurate instruments, avoid parallax, repeat everything, use averages, handle them carefully, and then correct zero errors. Is that really hard? So that means I'm done with everything to do with measurements. Please tell me in the chat, have I kept time? Is it already more than 40 minutes or less than? More than, less than? More than, less than? Because now I want to use about an hour or more for the dimensions. This is now the real work. Real work. Okay. Have we saved time? Have we saved time? So make sure after here you go to YouTube as I've asked. Okay, moment. Make sure you go to YouTube and watch. Okay, someone said less than by 2 minutes. Anyway, okay, now we are going to handle this measure dimensions. Most important thing. So, most of the terminologies in science, if you really want to get them, always first try your level best to find out what they mean in English. When you find out what they mean in English, now you can now come and relate to the science. I don't want to give you a task of going right now to Google or whatsoever to check the meaning of dimension, but you all know dimensions are to do with measurements. Let me ask you, let me show you that you know what the word means before even we read it in physics. If at all I put for you a rectangle like that, and then someone comes, oh, and I ask you, what are its dimensions? What do you understand? What are its dimensions? What do you understand? Or what do you reply? Okay, what do you understand? Not what do you reply. If I ask you for its dimensions, what do you understand? Exactly. Length and width. Something like that. So you at least know something about them. So dimension just deal with measurements. But remember what I told you, that we have fundamental and derived. The fundamental, the basic ones, cannot be expressed in terms of any other quantities, and there are three. That is mass, length, and time. Then the derived ones are derived from the fundamental ones. And that's why we say they can be expressed in terms of the basic ones. Is it okay? Now, we added and said they are the ones called dimensional quantities. Simply because the mass, length, and time are the main okay, I don't want to call them dimensional quantities, but you know length is a dimension. The mere fact that I've asked if I tell you what are the dimensions of the rectangle, you've told me length and width. So length is a dimension. Yeah, is a dimension. So don't overthink the word. That's what usually makes people forget the topic. And the moment you try to reason anything that is obvious in physics, you end up confusing yourself. When they tell you that when you're dealing with this is this, take it. When you get a slight explanation, have it. That's why you need teachers in this. Now I've guided you, so don't overthink the word. The mere fact that derived are dimensional, have it in mind. We are going to write them in terms of the dimensions of the fundamental quantities. So the question is, what are the dimensions of the fundamental ones? That is all. Have you heard? A rectangle has length, and we have said length is a dimension. And then we have said derived quantities are dimensional, simply because we can write them in terms of the dimensions of the fundamental ones. So now what are the dimensions of the fundamental quantities? Are three: mass, length, and time. So what are the dimensions of mass? What are the dimensions of length? What are the dimensions of time? Or we can correctly say, what is the dimension of mass? What is the dimension of length? What is the dimension of time? Period. When you understand that, we are done. Okay, those are the stories, and enough of them. So they are saying that dimensions of a physical quantity shows the way a physical quantity, derived quantity, strictly the derived quantity, is related to the fundamental one, and that is mass, length, and time. They are saying that the symbol of dimension is this. These ones are called square brackets. Those who do chemistry, you come across those square brackets and they mean concentration in chemistry. But in physics, they mean square what? Sorry, they mean dimension. So the square brackets in physics, they mean dimension. Square brackets in chemistry, they mean concentration. So in chemistry, when I say this, I mean concentration of X. In physics, I mean the dimension of X. Is it okay? So this one, so when I put for you X just like the way it is X, it is read as X, just X, nothing else. But the moment I do this in physics, this one is read as the dimension of X. Hope we are together. It is a very cheap topic, very cheap. So X alone, just read it as X. I mean, they put square brackets, now the dimension of X. Now, when you're reading the word mass like this, just read it as mass like that. But the moment you put those square brackets, it's now read as dimension of mass. Length as length, the word is just like that. The moment you put the square brackets, it's now read as the dimension of length. Time as time, the word time, just read it like that. The moment they put it in square brackets, now becomes the dimension of time. So the dimension of mass in physics is simply capital M. But in the textbooks, this M is italic. But for you as a student, you cannot write italic, even when you can, but not everyone can. Some people write italics unintentionally because of the poor handwriting. So as a student, just make sure you have a capital letter. Then the dimension of length is simply capital L. The dimension of time represented as capital T. But in the textbooks, you check capital, bold, and italic. But as a student, you can't do bold and italic, but at least you can do capital. So we take on the capital. Is it okay? So the very first thing you should understand from this class, and I know it is new to whoever is having this lesson for the first time, dimensions, capital letters, and they are strictly those three. Strictly those three. Others are going to come later. So why they are called dimensional? Because they can be expressed in terms of the dimensions of the fundamental quantities. Why I brought a rectangle and asked the dimensions, I wanted you to identify length as a dimension. And then you already know that length is a fundamental quantity. So dimensional quantity, that means are written in terms of other dimensions of the fundamental ones, where length is part. Is it okay? So the length had to pull the mass and time along with them as the CCTA fundamental quantities. Is it okay? So one thing you really need to know is that the dimension of mass is capital M. The dimension of length, how do you represent it? Capital L. The dimension of time, how do you represent it? Capital T. But you'll find in other calculations, in other topics as we calculate, you'll be like mass, and you use even small m. You say that mass is 3 kilograms. But this is just mass. You're not meaning its dimension. You're just on mass. Then you'll be like L, be like it is 3 meters. But this L, you don't mean the dimension. You just mean the length, the quantity. I know that people get the difference. And that's why in calculations time, we use small t, will be like time 3 seconds. So the time 3 seconds, the small t is the time, the quantity. But if you mean the dimension, it should strictly and strictly be what? Capital. And if you're reading a book, you should ensure that the book has endeavored to have it in bold and also to have it in what? Italics. Italics, we mean those letters that bend. So it should be bending and italic. Okay? Let me try to show people some tricks. This is what I mean. M, L, then T. See? Capital, bold, and italic. Italic simply means a bending letter. Hope I've tried. Okay. Now that is it. That is it. Now, what if they ask you for other dimensions? Those are the basic ones. Those are the basic ones. So the rest of the quantities, now area can be expressed in terms of length. That means that area is a derived quantity. Velocity can be expressed in terms of time. I told you people to watch the lesson of linear motion before we can have this, because some of the formulae we are going to bring them here, but people refused. So I'm not going to pardon anyone who never listened to instructions. So I'm going to just proceed straight away. So these three, those first three you're seeing are what we call the dimensions of strictly and strictly fundamental quantities. Now, what of the dimensions of the derived ones? Is it okay? So what you're seeing here, it is dimensions of fundamental quantities. There are three: that of mass, that of length, that of time. Now, beginning from here, we now want to look at the dimensions of strictly and strictly the derived ones. And we have decided to begin with area. Now, I want to first brief you a bit about how you're going to handle everything. So here, I've said you're going to deal with the dimensions of the basic of fundamental quantities. Hope you see the square bracket. So that means that one is also read as dimensions of basic quantities. Then I'm going to go to the next page, and then we are going to handle the dimensions of now the derived quantities. Yeah, dimensions of derived quantities. There are many. Now, remember, derived quantities cannot exist without the other ones. So also these ones, we are going to obtain them. So obtained from the capital M, the capital L, and the capital T. You get? So the other first three, MLT, they were the dimensions of the fundamental ones. Now you're supposed to look at the dimensions of the derived ones. Because someone may be like, oh, so what you mean, doctor, is that the dimension of area is the capital A. This is wrong. This is wrong. Because we believe these are the major ones. And all derived quantities come from any of these. So whatever we are going to be dealing with under derived, we should be relating them to MLT. So as you're getting dimensions of derived quantities, the letters expected, it is M, L, and T. M, L, and T, no any other. They're supposed to be obtained from those three, the basic ones, from the definition of derived quantities. So we are going to move slowly with them. Hope we are together. So the very first thing is area. Let us begin with area. Now I'm going to be giving you two options. Then you people are going to choose. And before we go any further, let me first give you the units as a recap. So for you decide which format you're going to take, a recap. So you all know that M is for mass, and mass is, okay, you all know that the dimension of mass is strictly and strictly capital M. And you know the unit for mass is kilograms in physics. Please, kilograms is small k. The moment you write capital K like that, this one means kelvins. You learned that also today. Small k is kilo, capital K is kelvins. Then you know that the dimension of length We have agreed capital L, and you know the unit is meters, not kilometers, not centimeters, meters. Is it okay? Then the other one is time. You know that the dimension of time is capital T, and the unit for time is seconds, not minutes, not hours, not days, not years, not months, not weeks. That is enough. Now, those are the basic ones. Basic quantities, fundamental quantities. Now, when the question comes and tells you that now help us, please, do for us the dimensions of area, you cannot come out and say capital A, because now you will not have expressed it in terms of the fundamental ones, MLT. So you ask yourself, what is the formula of area? Of course, area depends on the figure. There is length times width, there is side times side, there is 4 pi r squared, there is pi r squared, it depends, isn't it? But at least everyone knows the unit of area. So you may not get the dimension of area as the word area because the figures are many. So you cannot just say length times width unless they asked the dimension of area of a rectangle, but they just said area. So area, everyone knows the unit is square meters, isn't it? Square meters. And you know meters, okay, you know square meters are denoted like that. So when they ask you for the dimension of area, because of the square meters, we all know that meters are alone, M alone is for length. And you all know that length has a dimension, which is capital L. So the dimension of area becomes L squared. That is the first thing you need to understand in this lesson. And when you get it well and good, but you will still get the same thing. If at all, maybe you be like, what if I'm considering area of a circle? Area of a circle is pi r squared, isn't it? Pi r squared. You know that pi is just a value and it is 22/7. 22/7 is a constant. Who can write the word we said about constants? What are they? What did we say about constants, if at all you've been with me since the beginning? What did we say about those constants? What did we say about constants in the chat? Dimensionless. Thank you so much. Thank you so much. Someone has said it. We say that constants are dimensionless, so we don't even give them time. These days people say masanyalaze. So constant tetugenda jua masanyalaze. We are not going to concentrate about it. So we now concentrate on the r squared. Now you be like r squared. Ask yourself, of mass, length, and time, of these three, which one does radius relate to? Remember, we should always find ways of relating the derived quantity to the basic one. So you cannot tell me where radius is connected to mass. How? It cannot be connected to time. How? But it can be connected to what? To length. So do you see? So the radius is connected to the length. So it is in meters. So you like it or not, the dimension of radius is also what? L. So because of the L squared, we shall also derive there as L squared in the formula of area. If at all they tell you area, but area of maybe a rectangle, you'll be like, okay, it is length times width. But remember, you need to know, we need dimension, okay? So you come and say, this has been the formula of area. But now we need, actually, I shouldn't even waste a lot of time writing. I think we had it here already to save time. So rectangle, this was strictly and strictly for a rectangle. But I want to show you that we shall still derive at the same thing. So it'd be like area for rectangle is length times width. But we need the dimension of area, so we shall get the dimension of length times the dimension of width. Dimension of length, everyone knows it is L. Dimension of width has the same unit as length. So width relates to the fundamental quantity length. So its dimension will also be L. L times L, we shall also derive at what? L squared. That means for you to get dimensions of derived quantities, you can either use the unit or use the formula. Everything is okay. Everything gives you the right dimension. For example, velocity. Let's use velocity, the one that is there below. Let's use velocity. So let me first secure our document and I put here dimensions. Dimensions. Dimensions, okay? Now, let us handle velocity. You all know velocity is the elder bro of speed. They have the same unit. Someone is writing in my screen, you're called Benedict. I'm going to remove you from the meeting. You remove those blue lines. There are 3. If you don't remove them, for me, I'm going to remove you myself from the meeting. I don't want people disorganized. So velocity, you have 2 options. Remember velocity, I've said it is a relative to what? To speed. And their unit is meters per what? Per second. Okay? Then also velocity, those who attended linear motion, we define velocity as the rate of change of displacement. And I told you rate of change of displacement means displacement over time. If at all the formula is confusing you, that means you dodged. Displacement over time. Okay, let me hope Benedict. Let me hope him. I see him struggling. Okay, now this is it. You all know that displacement is the algebra of distance. Remember, at one point in physics, we are supposed to talk about scalar and vector quantities, but I taught it in linear motion, and I don't usually repeat myself. So distance is scalar, whereas displacement is what? Vector. Speed is scalar, whereas velocity is what? Vector. So if at all you want to use the unit to get the dimension of velocity, this is what you do. If you want to use the unit, you'd be like, okay, mass per second. Okay, let me teach you this. You just come and pick this. Meters is for length, and the dimension of length is, so you're like, I now want to get the dimension of velocity. You'd be like, the dimension, okay, this is meters, and meters belongs to length. The dimension of length is L, so you write L. Then you'd be like, this is S for time. The dimension of time is what? T. Then you bring this -1 and also put it there, and you're done. Or if you don't do that, you'd be like, okay, they now need velocity alone is displacement over time. So when I need the dimension of velocity, that means I need to get the dimension of displacement over the dimension of time. So you'd be like, but this distance, among the 3 fundamental quantities m, L, and T, distance is related to L. The SI unit is meters. That means the dimension of displacement is L. The dimension of time is T. You see why I taught you indices first before introducing the topic? Because I wanted you to realize and know that when this T is down as power 1, the moment I carry it on top like this, it becomes T power -1. So I get LT power -1. Let me write it clearly. Have here LT and then my power -1. So don't you see that it is the same as that? So I think you have realized that these dimensions are easy. Either use the unit if you know it, or you pass the side of the formula. Though the side of the formula makes it perfect. So you can just use the unit to confirm that really, yeah, the dimension is right. So you can see velocity is now in terms of what? L and T, where L and T are dimensions of known basic quantities. There are too many derived quantities. For me, I'm going to do a few. Then you are supposed to do the rest. Let me talk about volume. Maybe people will do density. Let me talk about volume. Though I wanted volume and density to be your assignment. So the first one was area. I had to do volume after, but I just wanted to go a bit complex. Okay, so look at this volume. Everyone knows that volume is mass over what? Density. Who doesn't know that? But then we have those who know a lot of physics, and they know very well that volume has a unit of cubic meters, isn't it? I think people know that. Cubic meters, isn't it? So if at all you need the dimension of volume, that means you get dimension of mass over the dimension of density, isn't it? But do you know the dimension of density? That is the question. So that's what makes the formula hard, or the formula hard at some point. Because now you're supposed now to first talk about the density. So that's where the unit helps. That's where the unit helps. So even if you use volume of figures, you still go back to the same dimension. So using the unit, you'd be like m alone is for length. Are we together? So that means the dimension for length or for volume will be L cubed. Are we together? M alone is meters for length, and the dimension of length is capital L. So volume will have a dimension of L cubed. But using the formula is now a bit what? A bit hard. So it won't work for volume. Are we together? Now let's see density. Density now both may hold. After all, now we've talked about volume. So density. Okay. Now you know that density alone is mass over volume. Very cheap formula. Now this is something I don't expect people to be having issues with. Now the unit of density, everyone knows it. Everyone knows it. Kilograms small k per cubic meters, like that. I've not lied. You can even just be getting it from this. You'd be like, okay, mass, the SI unit for mass is kilograms small k. Then the unit for volume is meters cubed. Then that means density will have a unit of kilograms per cubic meters. Or you can just write it like that. You remove the slash and put -3. Oh, those are rules of indices, but hiding here in SI units. 0K. Now, you can first hide that. Then you'd be like, if at all you're looking now for the dimension of density, you're supposed to get the dimension of mass over the dimension of volume. Then you'd be like, what is the dimension of mass? Capital M, because mass is a what? A basic quantity. So we come and put this. Then ask yourself, what is the dimension of volume? You have already obtained it there above. The dimension of volume is L cubed. So you come and write L cubed. Let me save space. Dimension of mass, that capital M. Dimension of volume, we have realized is L what? L cubed. Then we said that L can come on top provided you change that 3 to -3. So this is now what they call the dimension or dimensions or dimension of density. Even if you don't, now if you don't want to use the formula but the unit, you come. The unit is this. Then you ask yourself, kilograms measures what? Measures mass. What is the dimension of mass? Capital M. Then you come. Meters measures what? Meters alone measures length. You get what is the dimension of length? L. Then you just bring this -3 and put it there. Do you see that? So there is when both the unit and formula work. There is when the unit works only and the formula doesn't. There is when the formula does and the unit doesn't. You understand? So you just need to be flexible with either as a physics student. 0K. Now to test people and see whether people are with me, let's first try acceleration. I'm not going to tell you anything. You all know what they call acceleration due to gravity, so I believe you know the unit. And you all know the formula of acceleration from the lesson of linear motion we had, or that you had from the drive. So we are now going to cover acceleration as I hear from Mulungi. Yes, Mulungi, you tell us.
Good afternoon, teacher.
Yes.
Dimension of density, you told us it should be, you had written kilo, kilogrammeters per cubed, but with capital K instead of small k.
Oh, okay. Now the difference between the two, capital K is like this, then small k is like this. Is it okay?
Yes.
Yeah. You look at my K. I just try to ensure that these ones are not at the same height. Did you see that I tried?
Yes.
Yeah, so that's what I concentrate on. Provided these ones are not at the same height, I just take it like that. But know
Okay,
the
thank
difference
you.
so that as you make notes, you write the correct thing. Is it okay? Now, acceleration. I'm waiting for the dimension in the chart. But if at all someone is sure of it, raise up your hand, we do it together. So that people can maybe do force, others can try pressure. There are so many, but we're not going to do all of them. It's actually the uses of dimensions that are very nice. So acceleration, those who attended linear motion, you know the definition. Those who dodged it, you face it rough. Use the unit. If you don't know the unit and the formula, both of them, please quit physics. You cannot manage physics. If you're on right now, or if you watch this video from YouTube, and you cannot define acceleration at this point, and you don't know the unit of acceleration, you just quit the subject. You can't manage it. That's it. Okay. So if I'm waiting for you, I'm waiting for you. There are so many. Yeah. I think I'll also leave people with some assignment. People are quiet. Is the answer in the chat? I think people have passed. I think people have passed it. Yeah, because I'm seeing something familiar in the chat. Okay. Now, acceleration. We have two pathways. So the definition is rate of change of velocity, isn't it? That means if at all you need the dimension of acceleration, you need to get the dimension of the rate of change of velocity and then the dimension of time. Is it okay? Now we all have the dimension of velocity already. We got it together. It's here. LT power -1. So the dimension of velocity from part B, it is what? LT power -1. The one of time is just like that. Then you know indices. When this T goes up, okay, read for people. Okay, let me first put this one here. Then you know indices, same base and divided, sorry, same base and we are dividing, we subtract the powers, -1, -1, -2. Then I'll stop there. That is for the formula. But if it is hard for you, you can use the unit. You've always had acceleration due to gravity. This is what you use in physics, 9.81 meters per square second. You know whether people are aware. But they can give you a question inside the paper and they tell you for this number strictly use it as 10, G as 10. Yeah? Okay, but I'm interested in the unit. So this is the value they put at the front of the paper, 9.81. Then in math, use 9.8. But in physics, 9.81. Those are one of the challenges PCM and okay, students of the physical class find. Remembering that physics it is 9.8 and math 9.8 and physics 9.81. You usually find them using 9.81 in math and they fail. Yeah, because on the math paper it is 9.8. Okay, so the unit is this. So when you look at that unit, meters per, this, you just ask yourself, What does, okay, the meters belong to which quantity? Length. What is the dimension of length? Capital L. What of the S alone measures time? What is the dimension of time? Capital what? Capital T. Then you just carry that -2. Don't you see that they are similar? And that is all. Okay. Now, let us, I really need to, you write for me the formula of force. Write for me the formula of force in the chat. Formula of force and the unit of force. It is even on part F. Very perfect. Unit of force, formula of force. I just want one person. Unit and formula, unit and formula. So this is what we shall use for the formula. This is what we shall use. Has someone put them or not yet? M times D, that is wrong. I don't know where you're getting that formula from. But M times D is not correct. I think we already have both of them now in the chat. Someone has the newtons and then someone has the mass times acceleration. And that's what I wanted. Mass times acceleration, then the unit of newtons. Yeah? I was looking for someone to write it with small n. Okay. The unit is newtons. Now, do you see that this unit is kind of hard? You see? Now, how are you going to use newtons to really get the dimension? Unless you can define a newton, that's how you can survive. But the other formula is mass times acceleration. You get 0k. But now if at all they tell you, okay, you're supposed to write forwards, yeah, we are just beginning, so you're supposed to enjoy the subject. Acceleration. Now, if at all you need now, they tell you, please help us get for us the dimension of force. So you'll be like, that means I need the dimension of mass and the dimension of acceleration, isn't it? Yeah. Then you'll be like, the dimension of mass is capital M. The dimension of acceleration, we have just found it above. It's there, LT power -2. LT power -2. And then what do you get? MLT power -2. So that's what they call the dimension of force. But then you should know that this mass is measured in kilograms. This acceleration is measured in meters per square what? Seconds. So guess what? Sometimes newtons have a different name. Yeah? People call it, okay, it is this N, the denotion, but another name for the unit is kilogram meter per square second. I believe people know that. Are people aware? So that means the other unit of Newton can also take us to the dimension. How? You'd be like, this kilogram measures mass, and mass has a dimension of capital M. Then you go to this M. It'd be like M measures length, and length has a dimension L. S is for time. Time measures a dimension what? Okay, time has a dimension, capital T. Then you just carry this -2 here. Hope we are together. So I think that is enough. Let me only do for you work. Yeah, let me do for you work only, then you're going to do the rest. Okay, let's first give it a try in the chat. Work. The work, we are doing it together. Then the assignment is coming. We are ending with work, or what you can call work done. Work or work done. Yes, first try it down there on paper. Yeah, work done. You first give it a try. Work or work done. Work or work done? Work or work done? Work or work done? That's why I love physics. It's the most interactive class. Even when you're doing the things, they really make sense. But biology, you just talk the content. For you know it, the people you're telling don't know. Because with biology, I cannot tell you to pause and do something. To do what? Maybe we pause, you meditate. But with physics, we can at least pause and then you say something. I think that's why I got more grades in physics than biology in 2016. But then in 2015, I passed BCM. But when I compare with my results of PCM in 2016, physics grades were more than those of biology. But either way, I got 20 points in both combinations, so I excelled. So it's the comparison is a constant, it's dimensionless. Hey, you people know. But then if the people are giving me answers and not copying. Like, okay, they are learning this for the first time. People who always learn these things for the second time always give me a wrong impression, and I end up going so fast, and I end up leaving students behind, those who are learning things for the first time. So only and only always give me answers if you're learning something I'm teaching for the first time, so that we get the right feedback and statistics. Okay? Now, with work, people had the formula, force times distance. Yeah? And you all know the formula is joules, capital J. Joules like that. Okay? Now, so when you're writing kilojoules, small k, capital J, I think I also told you that in chemistry, thermochemistry, for those who do PCM. Okay, now, if at all I want to get the dimension of work or the dimension of work done, whatsoever, you need to get the dimension of what? Force, and the dimension of distance. So the dimension of force we already have. We have it here, just above. MLT power negative 2. So the dimension of force is MLT power negative 2. Dimension of distance. Aren't you aware it is the same as the dimension of length? And it is just what? L, isn't it? And then this one, indices. You see why I taught you indices first? You have L and L here. L times L is L squared. So you have M, you have L, you have squared, you have T, you have power negative 2 like that. But then someone could use the unit also. How? You have to be like, this force is in newtons, not so? Okay, we say this force is MA. Are we together? The force is MA. So the M, the mass, is measured in kilograms. Is it okay? Then the acceleration is measured in what? Meters per square second. Then the distance alone is measured in meters. So when these things multiply each other, guess what? The kilograms remain kilograms. The meters are 2, so they will be squared. The seconds will be square seconds per square seconds. You get? Now you can get the dimension from strictly this unit. That's why students who know physics called joules as kilograms square meters per square seconds. You see why they transferred these things to names, joules and newtons? Because they are very long. People can easily make errors. You see? Some even just call the unit Newton meter, because force is Newton and then distance is meter. Newton meter, or kilogram square meter per square seconds, or just merely joules. So kilogram measures mass and the dimension of mass is capital M. M alone measures length and the dimension of length is this capital L. So because of squared, we square. S for time. And then, you see, hope you are connecting stuff. So now I think that is all. We are now going to go to the uses of dimensions. Okay, now we are going to see what we have as our assignment. And let me see, here we have energy. I want to give you power, then momentum. Let me see. So velocity we have covered, length we have, acceleration we have, force we have, work done we have. So these things of power they are using. Of course, power is work done over time. Now we did work done. Do I really need to do for you power? So power is yours, energy is yours, pressure is yours, impulse is yours, momentum is yours. Yeah. Is it fair? The rest were done. Yeah. So this is a trial question. Yeah, trial question. So you do it. Now straight away go to the uses. Let's first check the syllabus book and see if we are moving. Okay, where is it? I think we are here. So explaining the meaning, I really told you a lot of stories and even got tired. So dimensions of the fundamental quantities, we got done. Using them to determine dimensions of different derived, we are done. Power assignment force, I did. Velocity, I did. Acceleration, I've done. Momentum, assignment. Others, some have done, others, it's assignment. Now, are you seeing only and only two remaining to hit the lesson targets or to hit the targets of the syllabus? Only two. So whatever we are finding this side is only and only under the uses of dimensions. We are done. The lesson is done actually. But now, what are the uses? So we are going to handle the uses and I'll say bye-bye. Okay. What do these dimensions really help us? They help us want to check consistency of equations. They help us to derive physical quantities. They help us to derive equations. They help us to derive or find units of the physical quantities, to derive or find the units of the unknowns in equations. They also help us to derive equations through obtaining values of unknowns. It will be very hard, and it is always very hard to ask you such questions of applications. If they ask, they need one or two. So you must start checking consistency and deriving equations, period. These are the things, if you know how to deal with calculations involving dimensions, then stating those cheap things is very easy. And these are things you're supposed to read towards the exam, 10 minutes to the exam, so that you can remember them very fast. Uses of dimensions, their applications, very, very cheap. Okay, now before we even proceed to the examples, I'm going to give you these two cheat codes. Yeah, the cheat codes you can only find in our books. Then we start straight away with the examples. We do something and I give you assignment, we end the class. Kinematics, I believe you have. Statics, forces, those things of resolution. I told you to cover them in math. That means the only thing you're not going with as far as senior 5 term 1 is concerned is maybe moments and couples in mechanics. Then, but you find them. Maybe people will listen to this later on. That is from March of 2026 and beyond. They will have all the classes. But at least I gave you most of the things to cover. Go to school when you know this work. You will appreciate when you're back. Then when you're back, we proceed with the holiday classes. Third term holiday, we complete the syllabus. You go to school, you don't come back. You revise all our work for a year. And what will stop you from getting the points unless you don't really work hard, because we have provided you with good content, well explained and understood. So that means now we have transferred the blame to you. The ball is now in your court. Okay. First cheat code. For a correct equation, the units on the left-hand side, so we are now dealing with the first use. I think this use. So we have looked at what do these dimensions help us in physics? How do we use them? How do we apply them? The first one was to test the consistency of equations, or what you can call dimensional consistency. And remember, units have been in play. And this is what we are saying, that for you to come out and say that this equation is dimensionally consistent, we should ensure that the units we are having on the left are balancing with those we have on the right. Or the dimensions on the left should be the same as the dimensions on the right. Are we together? And all equations that are correct in physics, physics has a lot of equations. A lot, you know that. Or you're going to know that if at all you're not aware. So provided it is correct, for you to come out that and say that is correct, it should be dimensionally what? Consistent. However, not all dimensionally consistent equations are correct. It's like in chemistry. Not all equations that balance are correct. You can balance a wrong equation and it comes out the same as physics. You can find an equation that is dimensionally what? Consistent. And it is not correct at all. So just have that in mind. When they ask you to check dimensional consistency, check if dimensions are equal or balancing or whether the units are the same. And stop there. Don't overthink about anything else. Are we together? What are they? Okay, what else are they saying? Cheat code 2. They are saying that when two quantities are added or subtracted, they must have the same dimension. This one we are going to see it as we calculate. Maybe to show you something, those who attended the lessons of linear motion, you realize I've been overstretching the point of you covering that work before you come for this class. So that most of the things I write are kind of familiar, but people don't listen. Don't listen. Those live classes you don't want to watch, they have helped so many students. Same content, same tutors. So don't expect anything different from a live class. Live classes are supposed to be for purely revision. So use the classes for content so that revision makes sense. The first equation of motion is this u plus at. So if you're to check that it is dimensionally consistent, the dimensions this side should be the same as the dimensions this side, or the unit this side should be the overall unit this side. They are saying that when two are added, so that is cheat code 1. Cheat code 2, if at all we add or subtract two things, or two quantities, they should have the same dimensions. What do I mean? You realize on this side, this is the right-hand side. Hope you are aware that this is the left and this is the right. I taught you that in equations in chemistry. Sorry to those who don't do it, but hope you've learned left and right. So realize that on the right, we have added u and we have added it to at. We are meaning that the dimensions of u should be the same as the dimensions of at. Let us test that so that people get it. Because I at least I trust people that they know the first equation of motion as v equal to u plus at. So let's use that to test the two cheat codes, and then maybe the rest of the things will be easy for us. So this is it. So I'm going to test cheat code 1 to see whether the left and the right have the same dimensions. Is it okay? Okay, now I told you that square brackets mean dimension in physics. So the moment I put something in brackets, I don't want you to be confused. Don't be confused when I put something in square brackets. Look here. So I'm going to come and say dimension of V. This side, I'm going to put dimension of U plus dimension of A, then dimension of small t. We are checking whether the dimensions are the same on the left and right. V is velocity, U is velocity, A is acceleration, T is time. the units will always help you to get the dimensions very fast. So you all know velocity is meters per that. Even this one is velocity. This one is acceleration. Hope people are aware that U is velocity but initial. V is velocity but final. All those things were explained. Then T, seconds. Are we together? So when you subtract the dimensions, you come and say, meters for length. So the dimension is L. S for time, dimension is capital T. Then a negative. Then you come this side. U is also velocity, so you come and do this. Are we together? Then you come and add. Okay? What do you have for A? A meters for length, L. T, S for T, then this -2. Are we together? Then you're multiplying it with. So never and never make a mistake of bringing back square brackets. Okay, then T for seconds. So dimension of time is that, isn't it? So you now come, first do the math. This one will be LT, this is -1. Then here you have LT, -1 plus L, this is T power 1, isn't it? This is -2. Same base, we are multiplying, you add the powers. -2 plus 1, you get -1. So you're going to just come and overwrite LT, -1. So let's even first understand. Let's first understand cheat code 2. Cheat code 2 is saying, if you know how to read, let us read it together. Cheat code 2 is saying, when two quantities are added or subtracted, they must have the same dimensions. Look here. They added U and AT. They added U and AT. Do you see that AT is coming out with this dimension? This one. And then also U is having this dimension. Don't you see that the dimensions are the same? Simply because they were added. Are we together? Then do you see that both sides have the same dimension? Because someone may be like, but why don't you add this side? No. Things being dimensionally consistent, don't mind. Because even if they tell you to add, even if you know a lot of math and you force yourself to add, which is not necessary, this side you will have 2, L this. Don't mind about this. This is dimensionless. The dimension is this and this. So don't even waste your time to add. The moment you're coming out with something and it is the same throughout, that means things are dimensionally consistent. I know that people have gotten it. We have used the equation of motion, okay? And we wanted to test two things. Whether it is true that when U is added to AT, those two things must have the same dimensions. And we have found out it is the same. U alone has given us this. AT gave us this and this, but they also reduced to the same thing, LT power -1. Then this side, okay, that is cheat code 2. U was added to 80 and each of them, we found out that the dimensions were shared. Then cheat code 1 of having same units on, having same units on the left and right, it was also coming out. My dear, the moment you get this one and you multiply it by this, you will come up with the unit of meters per second. Meters per second, meters per second, meters per second. So that of units is obvious, it should come out. Then that of dimensions, don't waste your time to add, provided this is the same as this as the other one. So now the question should be, if at all they ask you in an exam, do you really do it like that? Yes. You just conclude. It is the conclusion that matters. How do you conclude? You just put there the word, hence dimensionally consistent. If at all now they told us to show that equation of motion, the first one, is dimensionally consistent, the moment you reach that step, everyone is seeing the dimensions are the same throughout, so you just say, hence dimensionally consistent. Don't say a lot. Hence dimensionally consistent. There are those who try to make it better and say, since dimensions on the left, so that means dimensions on the left are the same as the dimensions or equivalent to dimensions of the right. Hence, the equation is dimensionally consistent. We just try to add in more soup, which makes it good. But even someone who just does that and comment, they are also safe. I don't know if we are still together. So let's look at any example that we had. So we have tested the unit, we have tested the dimensions, and we have tested the thing of added or subtracted. Now look at this. It was example 1. This is the second equation of motion. This is the second equation of motion, even if I don't write that. So they told you to check if it is dimensionally what? Consistent. Now, this S is displacement. And we say displacement is a brother to distance. And distance is related to length as the fundamental quantity. So its dimension is capital L. Hope you get that. But this is on the left-hand side. So when you see this, it means dimensions on the left-hand side. And it is only S whose dimension is L, for reasons I've given you. S is displacement brother to distance. Distance relates to length as the fundamental quantity. So the dimension is capital L. Are we together? Then we go to the right-hand side. The right-hand side is UT plus a half AT squared. Now, this is what I want to teach you. Remember we said that these constants are dimensionless. So you have two options. You either ignore their half, or you also tell us that the dimension of a half is 1. Are we together? Oh no, I think we didn't have that. And we should also make it part of our notes. Those things that we said are dimensionless, the constants. So we are going to say that the dimensions of constants, it is as simple as 1. Is it okay? So in your very solution, you can first show us that the dimension of a half exists, then after you replace it with a 1. Or if you can, you just simply ignore it and just proceed with other things. Is it okay? Hope that has been said and the point has been taken home. So when you reach something like this is now the right-hand side. Okay? You're having UT. So the dimension of U alone, but it is better you first show the examiner. Then now you're going to get the dimension of U, dimension of T plus dimension of half, dimension of A, dimension of T alone, then squared outside. Most of you do a mistake and you put the squared inside. That is bad. The squared is supposed to be outside the dimension. I think that is a bit obvious. So since you know that the unit of this one is meters per second, so you can literally tell its dimension. Is it okay? People, the things that are remaining here, it's algebra. Eh? So the dimension of U, you all know, because of this unit, it comes out as LT power negative 1. Then this one is time. Its dimension is just T times T. So we come and do what? And add. We proceed. Dimension of a half is just 1. So you come and add 1, then you proceed. What you have this side. A, it is meters per what? Per square second. So can you write the dimension of meters per square second? Yes. Meters is for length, capital L. It is here. S alone is for time. Dimension is T. Then you carry this negative 2. Do you see it here? Times time. Dimension of time is what? T. This squared, don't forget it, it is here. Then indices start to apply. Now, what do you realize here? Let me now remove this. Hope you've been following. Those arrows are there to help you follow. Then after I remove them and then put others. So you need to be extra attentive. Don't even blink. So this T we are having here is to power 1. So indices same base T. We add the powers. Negative 1 plus 1, you get 0. T power 0 is 1. 1 times L is just L. This is physics, so you don't need to show a lot of mathematics that is irrelevant. I don't know if we are together there. Even here, this side, t same base. You add the powers, -2 plus 2 is 0. T power 0 is 1, so it remains L. So do you see that in this equation, ut was added to a half at squared, and both of them are having the same dimension, L. It is the other cheat code too, that everything you add or subtract, you should make sure that in the end, to confirm your work, the dimensions are the same. Then on the left, we have also L. So do you see that the dimensions on the left are the same as those on the right? That means the equation is dimensionally what? Consistent. Is that really hard? Is that really hard? Now, I want people to do for me this. People, you do the third equation of motion. 2as. Because now this one, yes, this one looks like the one, this one looks like the third, but it is not the third because it's having wrong coefficients, and I'm going to talk about those wrong coefficients. Then I tell you the other note I talked about, but I want people to use the real one. Use the real one and confirm to me in the chat. I don't know whether people know how to send pictures in Zoom, but when you check the Zoom chat, it gives you that option. As you're sending a message, there is this car button. Let me teach you that car button because I want to look at people's work because the lesson is done almost. It's a few things remaining and they are also very cheap. As you send a message, there is this car button. If you can see it, it has a car plus there. It is like this. So you do this number, you do this on a piece of paper. I want to see your steps. After doing it on a piece of paper, you're trying to prove whether it is dimensionally consistent. Have your steps on paper. Then after, take a picture, press this, upload the picture. You'll be seeing the options. I'm also going to do the same number, but I'm going to first turn off my screen so that after doing it, I now share my screen again. Then we compare the steps. If you were not in position to take the picture, you just confirm that we have the same answers. But let me hope people watch the lesson of linear motion having this formulae. And when we get done with this, we shall be done with the targets of the syllabus. These are the things I'm going to add on. I just want to add them. I just want to add them for your own good because they are also cheap, but this is what concludes the lesson in actual sense. Adding on other things is just having a good heart as a physics tutor. So you people, you do that. V squared equal to U squared plus 2AS. Hope you have it already. Some of you are too lazy that you want to paste that into AI and you paste your answer of AI. AI cannot make you pass A level. A level is for some other things that are not the content you need. It to make you understand maybe something you're not getting well, but it cannot give you solutions in line with what UNEB wants because it is not updated unless UNEB gets its own AI for students. So avoid it if you can. So I'm now going to turn off the screen. I do the number. I have my steps. I just want you to look at your steps and mine. If they are the same, then you're okay. If they are not, it's quite absurd. I think you see that after that, we are going to look here down. We are going to use 2. Are you seeing this one? It is use 2, which is not part of the syllabus, but it is cheaper than what the syllabus put. Okay? Okay, let me hide my screen. Please don't go off. Please don't go off. Do the number as I also do it. Then later we get back and see how far we have moved. It's time up. It's time up. I think someone has sent something. Let me see. This person has made a mistake. Person has made a mistake, but very good try. Someone is just saying it's dimensionally consistent. Why? Okay, let's look through the steps. If at all we have the same steps, you confirm to me and tell me that the steps are the same and I have all the marks. So this is what you're supposed to check first. Check whether you have this squared. Not this. You're not looking for the dimension of v squared. You're looking for the dimension of v alone, velocity. So make sure you have strictly and strictly this. So don't have the squared inside the square brackets. So if you have something, if you have that step, you give yourself a tick. If for you ignored the dimension of 2 to later convert it into a 1, it is okay. But me, I just want to have completely clean work. I show the dimension of 2 because it is a constant dimensionless, I give it a 1. Okay? Now, because of this unit of v, velocity, I know m, length for L, s, time for capital T, then the negative 1, then I square. Is it okay? I think these things, you know them. Yeah? Even the last one is S, displacement distance related to length, dimension capital L. That's why it's coming last. Acceleration, that one we have oversaid it. So if you have this as the dimension of v squared, give yourself a mark. Dimension of this side, put a mark there. If you have that final one, give yourself a mark. If you have the final conclusion that since the dimensions of the left are equivalent to those of the right, hence that equation is dimensionally consistent, give yourself a mark. Just 3 marks. Though for us we have them as 5, but they are 3. Yeah? The first step that puts them there, the simplification, and then the conclusion. So if you have all the steps, just tell me in the chat, got it correct. Do I have more than 10 people who got it correct? With similar steps like the ones I have? Then the other thing, make sure that here you have curved brackets. The moment you bring back here square brackets, you're wrong. Because it's now like you're looking for a dimension of a dimension. So they are strictly supposed to be curved brackets when you bring in what? When you bring in or when you take away the square brackets, or when you bring in the dimensions. It's like saying in chemistry that the concentration of sodium chloride is 2 molar. Now you cannot come on 2 molar and again put this. It's like saying concentration of 2 molar. You get it? So avoid bringing back square brackets when you substitute for the dimensions. Someone said got it correct but didn't do step 1. It is okay, but why not? Do it. Do all steps. Okay. Now someone has asked for another example, but for me, I'm going to just give it to you as the take home. You see, even this one, it was coming out as you can see. Things were coming out. This was the left, this was the right. But remember, the equation was wrong. That's what I told you, that it's not that every equation that comes out as dimensionally consistent is right. So it's other methods we use for finding whether the constants are right or wrong. Remember here they had 8 and 4. 8 and 4 are not the right ones. But then the dimensions come out because constants are dimensionless. So this method alone is not enough to confirm that constants in the given equation is right. So never conclude and say hence the equation is correct. No, it's always hence dimensionally consistent. Okay, so we go to this as your assignment. So you take a screenshot and then you do it later. You have the group of physics scholars in the SSA community. Please try it out. Don't just be there talking about non-academic issues. You do that. screenshot, you can write it later. Okay, now use to. Use to, it is just the same as whatever we have been doing. It is not so much difference. Not so much difference. Okay, I'm going to give you others. I think I should also attach them. I think let me put them here. Yeah, I'm going to give you others for you to confirm whether because I've realized I don't need to do a lot of numbers for this thing of dimensionally consistent assignment. All you're doing is to confirm that they are dimensionally consistent, R. So doing a lot of numbers may not help you, but maybe I can guide you. This R is radius, so that you know what to do. This M is mass. This F is force. This is number 2. You already have number 1. Then this V is, of course, velocity. What else should it represent apart from velocity? Then we have 3. We're having V over T equal to, you're having pi r power 4. You're having P. Then you're having, oh, this one is serious. I don't know if people will manage, but you will. So that V is volume. So you know what to do. You're just checking if the dimensions on the left are the same as the dimensions on the right. You can first handle them separately, just like the way it is here in our book. You first handle the dimensions on the left alone, the right alone. When you confirm that they are really the same, you conclude. Or you can do like the way it is here in the workbook, where you do the left and right at the same time. The bad thing with that one, that you may reach earlier on the left before you reach the final thing on the right. But you just keep the discipline, you just keep rewriting it until things equalize, and yeah. Or you do the left alone, right alone, then conclude. So this V is the time. This P is pressure. This L is length. Is it okay? This R is radius. Are we together? Now this pi is a constant. Who doesn't know that pi is a constant? Now this one, you will learn it in the future. It's a coefficient. Most people may treat it as a constant, which is wrong. It's a coefficient of viscosity with dimensions. So it has dimensions, with dimensions m, l, power -1, then t, power -1. So I don't know whether people are understanding. In most of the cases, okay, all of you are here, I believe you can get the dimensions of volume, you can get those of time, you can get those of pressure, you can get those of length, you can get those of constants. Now, the problem was with this coefficient of viscosity, this one, So whenever a question brings in something new that you may or may not be sure whether it's a constant or not, they always provide its dimensions. So this is as you're substituting for dimensions, this is what you're supposed to substitute for this. You get? Others you can get and substitute. I don't really think they're hard. So you realize the rest of the things are just algebra. This is algebra, not even physics. The physics stops on getting the right dimensions, which I taught you. Now the rest is algebra. You try hard and make sure the left and the right are in touch. If they don't, you're gone. Hope that is okay. Now, other things will come in later. Yeah, they can really bring in things that are a bit hard, but you'll cover them later. For you understand the knowledge of dimensions. When they bring in other things that are hard, you'll be in position to understand. Don't worry. I think others you can do. Okay, now there is this question. Let me call it the exceptional trial. I don't know that people here have question banks of UNEB. Yeah, you don't know that people here have question banks of UNEB. But these numbers I'm giving you are a collection of UNEB numbers. I'm getting them from my notebook, but maybe I should also give you the UNEB number so that people can check later on. Yeah, so that people don't. But do you people have old question banks? I always see them moving on social media. Maybe you can check with time. So this is a number of UNEB, and it was, remember, mechanics has been paper 1 for some good time. So it is UNEB. So it is UNEB, paper 1, 1997, and it is number 1. Part A, Roman 2. Those who may want to check. Then this one, let me see here. It is 2005, of course, paper 1, 2005. And it is number 1B. It's number 1B. Okay. Now this is the exceptional try I've been telling you about. But it is not hard. It is also to do with dimension. So they gave you something like this. They gave you F. They gave you capital K. It is also in a number, of course, paper 1. And this is 2001. It is number 4A, Roman 2. So they gave you F equal to K. Yeah, let me just give it to you as the exceptional trial. The good thing you have this year 2001. You just try it. But the question was to show that that the constant K is dimensionless. Okay, I'm going to give you the hint. Let me give it to you. I will feel bad if at all I don't give it to you. So that one, then RV. You get? Now this F, of course, it was force. Everyone knows that this was force. Of course, this is a constant. This one is the coefficient of viscosity. This one is radius. This one is velocity. So you can really try. So they were saying that show that K is dimensionless. That's what they were saying. Show that K is dimensionless. And this is the hint. This is the hint. So I'm going to give you the hint for you to continue. So what is the first hint? You're supposed to first make K the subject. So when you make K the subject, this is what you will get. You will have F out of RV, isn't it? Then after that, you go for the dimensions because they are trying to say, make sure that K is what? Dimensionless. So you go for the dimension of F, which is force. All of you can get it. You go for the dimensions of this, which were provided. Dimension of R, dimension of B. Is it okay? Now the dimensions of these ones, they're here above, yeah? They're here. ML -1, T -1, the coefficient of viscosity. You get? Now my question is, if at all they are claiming that K is dimensionless, what should we get here? What should we get? People, if at all they are claiming that K is dimensionless, after substituting for this, this and this, what should we get? Tell me in the chat. 1. That is it. We should get 1. So the moment you get K as 1, then you conclude and say, since that, then K is dimensionless. I think I don't need to put that in writing. That's why I always request you to have your notebooks ready. So I've said a lot on this number than we actually have on the board. So the moment you get the 1, you conclude and say, since the dimension of K is coming out as 1, hence K as K is dimensionless. As simple as that. You don't do any other thing. Okay? Now, the other things that are remaining, they are easy. Because for them, they are just to do with bringing in constants. Okay, it's just math. So according to the syllabus, we are done. We are done. We have overchecked consistency and yeah. So I also put a tick here. These things of demerits and merits, these are advantages and disadvantages of which I've been mentioning some. For example, it cannot tell whether the constants are really right. So that means we are done according to the syllabus. But for me, there is something extra that I really want to give you. And please wait for it. Because this very book of ours has notes, of which this very book of ours has assignments, which you're supposed to go with. Yeah, the assignment is here. So who are you leaving the assignment for? Are you seeing it? Assignment is there. So wait for the assignment. So what we are going to do is not hard, so you stay on. Okay, so use 2. Use 2. This is what they usually do. I want you to read this statement. Let's read it together. So we have about 5 minutes to end the class. You see, we have only one page. That is the page we have. This one. This page is a half. It's not even a full page. Then the trial questions. So stay on for only one page. We leave, yeah? So use 2. So maintain the number that is there. And thank you for maintaining that little number. Yeah, thank you for being endurant and perseverant engineers. So they are saying if one has an idea about the factors upon which a given quantity depends, the method of dimensional analysis can be used to derive equations. Do you remember that as one of the what? As one of the uses that we can really use it to derive equations very well. And deriving equations is like even getting constants. You're going to see that. You're going to see that. You're going to see what I mean. And if you recall, under the uses we said, as we derive equations, we are getting values of unknowns. Those who took the screenshot. It's there. Do you see the uses? You check the last use. It is saying to derive equations through obtaining values of unknowns. So we are going to be hitting 2 birds with a single stone. So provided you have an idea about the factors upon which a given quantity depends, then you can use dimensional analysis to derive equations. What do I mean? For example, here they are saying that let's consider oscillation of a single pendulum. Those who studied waves with me, the lesson is even there on YouTube. Hope you know what I mean by oscillation. So we are saying that let's consider the oscillation of a single pendulum. The period T, capital T, may depend on, so they are giving us the factors on which a given quantity period or periodic time is depending on. And that is mass, length, and the acceleration due to gravity G. So you like it or not, we can obtain the equation. You like it or not, we can obtain the equation just because of this word depend. And depending in mathematics means directly proportional. If you depend on your parent, that means you're directly proportional to their finance. They get a lot of money, they give you a lot of pocket money. They take you to a school paying 5M. That's why you're seeing the word depend, but as we bring in the math, we have this symbol, the proportionality symbol. And these are things we are going to do very easy. So understand this use, that if only and only you have an idea of the factors upon which a given quantity depends, then we can derive equations. And in the course of deriving equations, we end up obtaining values of unknowns. And that's what we are going to look at. So let me first help you in the book, and then we see our notes. And I think that will be all. I don't need to do a lot of numbers on that. It is very cheap. So use 2. Let me call it case 2 here. So they told us that the period that as a pendulum is swinging, the period, the time it takes to make what? Complete oscillation. T depends on, and after you depending on is proportionality. Is it okay? It depends on 3 things: mass, length, and G, which is acceleration due to gravity. Did you read the statement well? Consider oscillation of a single pendulum, simple pendulum. The period T may depend on mass, length, and G. So I'm going to come and say directly proportional to mass, directly proportional to length, directly proportional to G. Someone may be like, why is it like that? Why didn't you add? This is the reason. They are saying that the period is directly proportional to M. The period is directly proportional to L. And the period is directly proportional to G. Hope you know that T is for period. Then, mathematics has it that if at all the same quantity is directly proportional to 3 different factors, then we can generalize it and say it is directly proportional to the product of those what? Of those factors. Hope we are together there. But remember, these factors are changing in a given way. Yeah. So you cannot just put MLG, no? You're supposed to understand how do they really relate. So it's not just M alone, they have powers. So M should be relating to T with an index of X, L with an index of Y, G with an index of Z. I know that people are getting me. So have it in mind. You cannot just say T. They have just told you it depends. They have not told you T directly proportional to M simply means that as T increases, even M increases. As T decreases, even M what? Decreases. You get? But when they say it depends, you're not sure of how the dependency happens. So there is a power. What if it is M squared? What if it is a half? So you really need to know. So as you're deriving the equation, you're not sure of the power. And then as you recall, maybe if you want to really recall this, just remember that as you're deriving equations, you're solving for unknowns. So the question is, which unknowns really are you talking of here? The unknowns are those powers which you're not sure of. T may be directly proportional to L power 4. But the same L can be directly proportional to the square root of L. So we are not sure of the power. All we know, T depends on L. That's all we know. So as we are deriving, we are not supposed to just, because when you leave it like that, you're meaning M power 1. But are you sure? You're not. So you're supposed to put those powers. You can use ABC. Use powers that are not any of those letters. So you cannot use M and N because M is already somewhere. So for me, I've used X, Y, and Z. Now, what next? You all know that the moment you remove this proportionality sign, two things come in place. The equal sign, then the other thing is the constant, maybe K, like that. But you all know this constant is what they call the constant of proportionality. But again, it is dimensionless. So we come up with a general name called the dimensionless constant of proportionality. Hope we are together. Dimensionless constant of proportionality. We go. If I told you you're lost, you raise up your hand. I told you it's hard for me to follow up the chart. So we are saying we are now getting something new. T equal to the small k. We're having the M. We're having the G. We're having the L. We're having in any order that you want. No one should scare you that a certain order is required. That one is not right. But now remember, what are we really going to? Remember, we are supposed to use dimensional analysis. So after that, dimensions come in. Yeah, dimensions come in. Don't forget that we have X here. Okay, we had MLG, but I changed the order. MLG, I want to maintain everything. Power X, L power Y, then G power Z. Or you can use A, B, and C. Anything that you want. Please make sure you write Z very well, small z like that. Now you proceed with the dimensions. This side we are having period T, which is time. The dimension of time, everyone knows. Okay, you can first do this. Now, the problem is 1. Period is represented by capital T, but even the dimension of time is represented by capital T. So you putting T in square brackets may bring some confusion. So you can first maintain it like that. Period is time. Then you also come here and say dimension of the constant K. I've told you, stay here, don't run. And people are here, I like that. L, Y, G, then Z. You see, that is very important. Then you start. It'd be like period is time. What is the dimension of time? Put T. We already said that K is the dimensionless constant of proportionality. What do you put? You put there 1. Put there 1. Is it okay? M is mass. Dimension of mass is just M. Don't forget the X. L is for length. Dimension of length is capital L. Don't forget the what? The Y. G is meters per second, isn't it? Meters per second. Meters is for length. Are people aware? But then there is something I want to tell people. G is 9.8 meters per square seconds. So what is its dimension? This is where I'm going to realize. Okay, this is when I'm going to confirm whether I have physics students or not. You tell me. What is the dimension? You write it in the chat. What is the dimension of G? What is the dimension of G? You realize why I didn't want you to go off. What is the dimension of G? Now people are going to overthink. Overthinking, which is bad. Okay, don't overthink. The mere fact it is acceleration, even when it is due to gravity, it has a unit. I want you to listen. It has a unit, it has a value. So the mere fact it has a unit, it has a value, so it is a physical quantity. But remember, acceleration is derived, so it is dimensional. So you cannot call it dimensionless. Those who are overthinking, it cannot be dimensionless. Yeah. Don't say it is a constant, yet its value changes 9.8, 9.81, 10. But it is a physical quantity. So that is bad. So some people had it. The unit is m, this like that. M for length meters, S for time like that, then negative. That's what I have. Okay. Now the next thing I'm going to correct like terms. So this side, I will have the T alone. Are we together? T alone. Then this side, M is just alone also. So M will have the X on top like this. Is it okay? Then L. L is having, don't forget this Z. Yeah? Hope we are together. So that L is very different. The L is having this Y, but it is also having this Z. Do you see that? So there are two L's, same base, different powers, Y and Z. We add the powers. So here we shall have Y plus Z. So this one is Y plus Z. Are we together? Then the last one is going to be a T. So what do we have for T? We can have T in brackets. Then T, I think T is just negative 2Z if I'm not mistaken. So after having that, we now compare both sides. Hope we are together there. So there are someone may be like, but we're only having T and T. Where is L and M? They are here. You have M here with power 0. You're having L here with power 0. Because M power 0 is 1. L power 0 is 1. You get? So whether they are there or not, just assume they are there but with powers of 0. Now you start connecting. Now this one is 1. So you come and say, equating powers. Then you come and say for M, can begin with M, no problem. Or you begin with the one that is easy. You realize M is going to help us get X very fast. So you come and say for M, X is equal to 0, tick. Then you realize you cannot go to Z because you cannot go to L because it has 2 of them. So first go for T, you get Z, then come for L. So you come and say for T, you're having negative 2, Z equal to 1. And then this one is giving us Z alone as negative a half, like that. Then you go for L. L is 0 this side, the other side is Y plus Z. So you come and say, for L, L is 0 equaling to Y plus Z. But Z is what? Negative a half. So plus Z, which is negative what? Half. Then you get Y as a half. Is that really hard? So we are getting Y as half. But remember, we all know that K is dimensionless. Simply that. So where are we? So now I think I'm going to come and remove these ones because they were not part. Even this one on top of T, I remove it. Hope people are following. So do you see that we now have the values of the unknowns? Now you come and say, therefore, equation is, well, they want you to derive the equation. Equation is T was equal to K, M power 0. Remember, X is power 0, M power 0 is 1. So don't do anything. Y and Z, they're also power 0. Do you see that? Hey. Let me first do it for people. I may panic. People get confused. So we're having t here, having the k here. We had our m power x, but x is a 0. Then we had our l, y plus z, which was a half plus negative a half. Then we had our t, which was negative. To z like that. Sorry, people. I think I'm tired, yeah? And no one is alerting me. This was our equation. This one. And people are just watching me substituting in a wrong equation. If we obtained the values of what? X, y, and z. They're the ones we are substituting for. And the relationship between t, mass, length, and g. Then we use dimensional analysis to get those values. So don't forget the equation we used. Sorry for that, but I also don't blame you because it's our very first example. So this is where we are substituting. I think you see why I just wanted to write the equation. So I'll come and say therefore, I'll come and say t is k, therefore we had m alone, which was to power x, l to power y, g to power z. Look here, m is to power 0. Are we together? L is to power y a half. Then g is to power z, which is negative what? Half. Isn't it? Now, if you know math, t will have the k. Are you seeing? Then this one will be 1, isn't it? Then this one will be the root of L, isn't it? Then this one will be 1 out of the root of G. I don't know whether people can see that. Do people see the 1 over root of G? Because that one is the same as 1 out of G power half, where G power half is the root of G. I don't know if we are together, people there. Then we come up with K, the root of L over G is the equation. I want you to look at the whole question from where it began from, and then you tell me whether it's okay. So they just told us we have T, which depends on mass, length, and G. Now we don't know how it really depends. Okay, we don't know how T depends on each of them, whether M is to power half, whether a quarter, whether what. When we just leave it as M, we are like it depends on M power 1, but we are not sure. So we are supposed to put their powers on each of them. Then how else can you recall this? You'd be like, if at all I'm to derive an equation, I will always need to solve for unknowns, which unknowns are the powers. So directly proportion is replaced with an equal sign and the dimensionless constant of proportionality. After that, I introduce dimensions on both sides. Dimensions will help me to get the values of unknowns by simply equating powers. If at all I have m on one side and on the other, the m exists but has a power 0. So I equate powers, then I get the values. Then after, I go back to the equation, I substitute. Then I get the equation that they want. Do you see that it's not on the syllabus, but it is important? It's actually there. The mere fact you're supposed to learn dimensions, maybe it was just an oversight by the writer. but it is very cheap and necessary. Okay, now I want 10 people to confirm the number that is here is enough. Only 10 people confirm to me that the number is okay. I give you one. You do the next week go because it is only one number remaining. But I want people to do it, not me. I want people to do it, not me. So first confirm to me whether this one is okay. Confirm to me that this one is okay. First confirm to me that this one is okay. You can breathe out a bit in and out. No, those who are saying not okay, raise up your hand and ask. Where is the problem? Some people are saying the Z. Which Z? Which Z? I'm not getting what people are saying. Which Z? The problem people don't want to raise up their hands and ask doctor at that step where I did this and this. I'm not getting this and this. You cannot just say not yet. What do you mean by not yet? Which part? Maybe the other things I rubbed off have confused people. Or people are confusing the 2 and the Z. But the people who understand this work, when you see your friends struggling in the chat, you please help them. Maybe that step for L where I said 0 is equal to y plus a half. It was y plus z, but z is a half. So when a half goes the other side, I get positive a half. I don't always want to say those steps. I always just want to write it, you'll have a look at it. Every time I don't explain a mathematical step, but you get it on your own, you get a certain vitamin. When you reason something, you solve. So is it okay we go to another number? But the next number is yours, not mine. You're saying the Z was already fixed. Where? Oh, I get. Sorry. Okay, now this second one is yours for you all. I'm seeing people disappearing. I don't know why. So I think you can see. Here the thing came out very well. Okay. Now, as I told you that this method of dimensional analysis does not deal with constants because they are dimensionless. So it cannot give the value of the constant k. However, there are other mathematical methods that give that value as 2 pi, and we shall see them in the future. So that value is supposed to be 2 pi, but don't show it here because we know dimensional analysis cannot help us. So this is the second number and it is yours. You're supposed to do it before you go off. So they are saying the period of vibration of a liquid is given by this formula. So right now you thank God that the formula has been provided, but let me tell you now the behind the scenes. They are giving it to you like this. This one is rho. It's not P, it is rho. Power Y. This is now gamma. It's not Y, it is gamma. So it's like this. It's like that. Then this is Z. So here they have already even introduced the constant themselves and they have helped you put the powers. That means in actual sense, the period depends on this letter A, it depends on this rho, it depends on this gamma. Yeah, that letter is read as gamma. These are Greek letters. That means in actual sense, they had this one first. Actually, the constant is not always there, but they said the period T is directly proportional to the A. directly proportional to the rho, directly proportional to the gamma. And then they said, we really don't know how they really depend on each other, or one depends on the other. So we need to attach letters, and they decided to attach Y and Z. So this was a very good question. Then after they removed this sign, put equal sign, and the proportionality constant that is dimensionless. So here you just thank God when the equation is provided. So that means here they may not ask for the equation. That's why they're only asking you to get the values of what? X, Y, and Z, but strictly using dimensional what? Analysis. So they are proceeding and they are defining each of them. They are telling you that K is a dimensionless constant. A is the radius. So don't think that each and every A you see is acceleration. The moment they tell you that it is radius, that means its dimensions are going to change. Rho, they are telling you it's the density. And the gamma, it's not Y, it's gamma. Just because that's how it appears on a computer. And they're telling it is the surface tension. So you realize you may find issues with dimensions of surface tension. That's why the question has provided them. So in most of the cases, for quantities whose dimensions may be hard for you, according to the thinking of the examiner, they will always provide them for you. Is it okay? Now, this is what you're doing before you leave, before you guys leaving. I don't know why people are disappearing. Why do you easily give up? So they said that the period of vibration T depends on radius, depends on density, depends on surface tension, but we don't know how. So we have our X, we have our Y, we have our Z. But this one is supposed to be substituted with equal signs and a constant. You understand? Okay, what do you come out with? Come out with T equaling to K. So in this question, they just provided you with this already. It is rho, not P. Rho, you can write it like that. Then the other one is C, gamma. So write them well, and you're going to come across them so much in physics. So use this chance well to practice. Then this one is Z. So what is the question? The question is to use dimensional analysis to get the values of X, Y, and Z. So I'm waiting for those values in the chat. Those who will have them on paper, you send them on paper. And me, I believe people have already started calculating for them. Someone is still waiting even after you read the question. Strictly use dimensional analysis, not anything else. Find X, Y, and Z. Find X, Y, and Z. So this T, I repeat, this T is period. Are we together? And you all know period is the same as periodic time, so it is time. This one is the dimensionless constant of proportionality. Then this A, they said it is radius. Introduce dimensions on both sides and do the needful. This one is density. So I believe people know how to deal with density. Then this one, they said it is surface tension and they told you its dimensions. They gave us that MT -2. That's what they told you to use. Yeah? But they said it is surface tension. So don't even complain. Okay? So I don't know. There is no other information that you're missing. So do it. They just need the values. Don't even waste your time to substitute and get them the equation. They know it. They even provided it for you. For them, they just want values. So we are simply getting those values. I give you assignment, then you go. Yeah. So even those who will be listening to the recording, use the remaining minutes to do the chinamba. Get the values. Get the values. Get the values. Yeah, I think we are done. I think we are done. think we are done. I don't expect anyone who really wants to become an engineer to go off. For whatever reason, you're supposed to stay here and we push. What are people getting? I want to give you the assignment and also show you how cheat code 2 is examined in UNEB. Your total numbers are about 4. They're about 4. And I'm going to do for you one using the idea of cheat code 2 that I gave you. Okay? Yes, stay on. Stay on and do the number. Yeah, I can see two people already have the answer, and those people are enough representatives at least. Yeah, in respect to the number that is on, yeah. So you can see here, x is 3 over 2, y is a half, z is negative a half. Yeah, the z is negative a half. Same steps, but someone has the answers. When you see someone posting the answers in the chat and I say they are correct, send them a private message. This is Zoom. It can allow you send a private message to one of the participants. Ask them for their WhatsApp number for consultation. After the lesson, you inbox them, you consult. You see? Now you're going to do that number. Yeah. You send them a hi. They can help you after the class, okay? Then I also sent you the consultation number of physics. So it's all about algebra. Can you write the dimension of density well, that of radius well, that of time well? You have that of surface tension. Apply the algebra, equate powers. So this is also an assignment. So you can see this time round, they provided coefficient of viscosity and provided its dimension, just like they provided that of surface tension. But they believe you know that K is dimensionless, the volume per second is nothing. You get the point. But the good thing, this one has the solutions below. So you can even check. But they are nothing at all. And here they just want one value, a value of x. Because it's the only unknown there. You see? This row, they are calling it pressure. But in the previous question, it was density. So you're supposed to be reading always. Hope we are together, people. Then everyone knows that this L is length, this one here. Really, do I really need to do that number? It only has one trick, that this is volume per second. So the mere fact they are saying volume per second, we have volume over time. Volume per second. I told you that in linear motion, when they say per second, or the rate of change of volume, things like that. The constant K is here. Then they are having rho and its power x on top. And then down they are having their coefficient of viscosity and then L. It's even like the chi number I gave you as assignment. Yeah, I gave you this chi number as assignment. It's here. It's a UNEB number. Do you see it? Though this time round we have different values, but it is related. And here they have rho calling it pressure, but the other one was P. You see? This was about checking dimensional consistency, and this one, same format, they want the value of x here. So please, you do it. So that's an assignment. Take a screenshot with even its answer 4. So that, because I believe you're matures, first try out before you copy. When you fail, you check and see where you've gone wrong. But you see, it's doable. It's about someone who can really handle the algebra well. The algebra of this side and the algebra of this side. And then find ways of equating what? Powers for the common dimension base. You all know this one will be out because its dimension is 1. I don't know if that is really hard. Okay. Now, okay. I see someone struggling. Let's do this. Okay, let's do this last one. Let's do the last one. Let's do this last one. I want people to complain. So they said volume per second, which is volume over time. Is it okay? Then they gave us this formula. I've just tried to rewrite that formula like this. Hope that is okay. Now, the next thing, they want you to use dimensional analysis. What is the dimension of volume? Dimension of volume is L cubed. I told that. What is the dimension of time? Dimension of time is t, like that, isn't it? Then you go. What is the dimension of k? It is 1. This rule, they are calling it excess pressure. So now you should just ask yourself, what is the dimension of pressure? Now you should know that pressure, from the definition of pressure, pressure is force over area. Why I didn't want to do this, it was in assignments. So force, you should know that force is MA, isn't it? The dimension of area, you all know it is L, this. The dimension of mass is capital M. This acceleration is m, s, -3, 0k. So the dimension of A, M is for L capital, the other one is T, then power -2. Are we together? I don't know whether we are together. So when you divide this by L squared, do you see that this L here is L power 1? So this is L power 1 up, then down you have L power that. That means the whole pressure, M will stay, but L will turn into -1 because of 1 minus 2. Then the T will stay with its power -2. Are we together? That is pressure alone. Imagine, only pressure. Remember this A, according to the question, A is radius, which is L. Is it okay? So I'm going to come here and say the pressure is ML, negative this, T this. Then the A is radius, which is just L, okay, over. This one is the coefficient of viscosity, and its dimension was provided. ML, ML and T, both with -1. So the other one is M, L, -1, even T, -1. Is it okay? Then you have L at the end, where L is just L also. Is this really hard? So you come and cancel things. This one cancels. You see? This one cancels. This one cancels. Do you see that? But remember, this A, the last one, sorry, the A cannot cancel because it's having, I'll beg your pardon there. It has X, eh? Sorry. It has X. But these other ones are cancelling, isn't it? Let me see if anything has been forgotten. Are we there? You people tell me, are we together there? Should we proceed? Let me first remove all these lines I cancelled. Hope people got how I've substituted everything. Me is red. So I'm like, this M is going to cancel with this M. Eh? This one is going to cancel with this. Now the T's cannot cancel because they have different power. So I can first hold on. Then even the L's cannot cancel because they have different power. The other one has power X, this one has power 1. Is it okay? So I'm going to come. First hand on the left. This is my left. It was volume over time. Eh? So it is L power 3. Then the time is like this. When that T power 1 goes up, it comes as a negative. So this side, you have remained with L power X minus 1. Laws of indices. L is dividing L. L on top has X. L down has 1. Then we also have T. T on top has -2, T down has -1. So -2 minus -1, I end up getting -1. Do you see that? I don't know if we are together. These things are not hard. You just need to make sure, can you write the dimensions of each derived quantity? Yes. Can you now handle the algebra? Yes. Can now you look for the common bases on both sides and equate the powers? Yes. So now I'm going to handle the L only. So this is L, this is L. The T is out. I'm looking for X. and t doesn't have the x I'm looking for. So I come equate this 3 and this x minus 1 because they're the ones on L. T is even cancelling. So I'll say equating powers for L, 3 is x minus 1, and that's how I get x as 4. So I saw that student who was confused in the chat. I don't know if now things are now better. The one who had called, I think the name was Charm. So people confirm to me that that number is okay. Can I give you other numbers, however hard they may be? Do you realize these things are not hard? If you can get if at all you have the right equation, you substitute for dimensions well, handle the algebra, look for which powers to equate that have a common base. I don't really see any challenge here. Okay. I'm seeing someone saying, yes, sir, we go on. People are serious. You can see the next topic is chapter 2 statics. So we have really moved. I told you for me, it's hard for me to leave class. Now, this is the number I want you to look at. This is the last one. Eh? I told you there are 5 questions and I want you to go with 4. This one is yours. This one is yours. This one is yours. This one is yours. So this is assignment. Yeah. Assignment. 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 I want you to look at this number. This number does not need a lot of working, but it may confuse you if at all you're not sober. So let's just read it. You first take that assignment. Take a screenshot of that work. Then we read the number and then we leave this place. This is the last one. They are saying for streamlined flow of a non-viscous incompressible fluid, the pressure P, so this P is pressure. You understand? At any point is related to height h, so this h is height. And velocity v, so this v is velocity. Then they are telling you A, B, and D are constants, but you look at where A, B, and D are. A, B, and D. Then they are saying that rho is the density of the fluid, D is the acceleration due to gravity. Given that the equation is dimensionally consistent, so they have even told you that. No need of you finding out. But for them, they just want this A, B, and D, and also they want their units. They want the values of A, B, and D and their units. But they have already told you everything is dimensionally what? Consistent. This is what takes us back to the other cheat code 2 I've been telling you, and I want you to read it again, then we just apply it here. It's there. They are saying where 2 quantities are added or subtracted, they should have the same dimensions. Where 2 quantities are added or subtracted, they should have the same dimensions. And you all know dimensions and units are just the same because you know dimensions come from units. So the mere fact that you have same dimension, that means even you share a unit. You understand? So someone may be like, how does that relate to what you are talking about? So when you read that question, this one, question 2, do you realize P was minus A? They had P minus A. Hey, they had P minus A. But remember they said the P is pressure. But remember they said that the moment you subtract 2 quantities, they have the same dimension. So A has the same dimensions as P, but P is pressure. So you're supposed to come and say that the dimensions of A you people are asking me for, they are the same as the dimensions of P. E. But then you all know dimensions of P, you know how to get them. Force over area. I think they're even still here in the book. Where are they? Where is the dimension of pressure? Do you see it? MLT, L is -1, T is -2. Do you see that? So you come and say, P, M, L. We have said this is -1, this is negative what? -2. Why they are telling you hence the unit? You're supposed to come and say hence You come and get the unit. M is for mass. Mass is kilogram. L is for length. Length is meter. You put the -1. T is for time. T is seconds. You put this. So this is the unit. You get? You just get the unit directly from the dimension. So A is done. They also wanted B. When you read this question, you see where B is? B is on H minus B. And the H was height. So we come. H minus B and H was height. H minus B. So you just tell them, because of the H minus B, these are two different quantities being subtracted. So the cheat code says that they share a dimension. So you just say that the dimensions of B you're asking me, they are the dimensions of the height H. And the answer of H is length. So its dimension is what is L. And the unit you want is meters. You get this mark, you get this mark. 2 marks free of charge. Then the last one. Look at the question. They wanted D. D was subtracted from V squared, but V was velocity. So you're supposed to come and say, remember, it was V squared minus what? Minus D. So you say that the dimension these people are asking you, it is the dimension of V squared. But everyone knows velocity, the unit is M, this. So the dimension of V alone, M is for length, S is for time, like this. But it is what? Squared. So the dimension is L squared T -2. Then the unit that they want, length is M, so it is M squared meters. I can't even say the unit, but I can write it. So you people, is that a question hard? Do you see that if at all it is asked, you can end up overthinking, yet it's about mastering the cheat code. That whatever they add or subtract, same dimension. So if they want the dimension of A, because it was subtracted from P, they share dimension, and P is pressure. Pressure is force over area, so you handle it. Getting the unit, get it from the dimension. H minus B, they need the dimension of B because it was subtracted from H, they share dimension. Dimension of H. H is measured in meters, so it is length, dimension L. Unit meters. Obvious. Is that really hard? I think the number is cheap. I want 10 people to tell me the number is cheap. 10 people. I want 10 people to tell me, doctor, the number is cheap. If you don't reach 10, I'm not going to end the class. I'm going to teach up to 8. I want 10 people because we may be here and people are not actually studying. When people may be slept off, how can you sleep off in a physics lesson? I want 10 people to tell me the number is cheap. So far it's only 5 people. Where are the other 5? Okay, more 3. Okay. So that means the rest of the numbers you're going to do it. Yeah, the other numbers are yours. I just wanted that number. I was going through the trial questions. I realized the rest are doable, but that one was very hard. So I don't know if people took the screenshot. Okay, let me give you a chance. You take the screenshot because I may not send you the book of Science Scholars Academy, but I will send it with time. Yeah, but you take the screenshots, please. We can split them. Okay, you take that. I'm going to end with the UNEB numbers. Yes, you're going with the UNEB numbers. I'm giving you UNEB numbers. You're going to do so. Way to disappear. Some of you are good at disappearing, so don't disappear. I'm going to give you UNEB numbers that you're going to post for your friends. That I'm going to just state the years. So that is done. Also take that. Yeah. Hurry. And also take that. You need to be very fast. Take that. Okay, then these ones you can take at once. Take that one at once. It will be very clear by force, but take the research and everything serious. You need the syllabus books, especially this one of ours that is student friendly, so that you get to know the work your teacher may leave out. You remind the teacher in peace, and you remind them very well, not in a way that will make them to hate you. You take that. I need people who are organized, people who can take screenshots, organize them into a PDF, and share to their friends. But I don't see people doing that. I don't know why. For the other workbook, I'm going to share. But okay, I'm going to give you the book. I'm going to give you the book. You may say you have a bad heart. But also take the screenshots and go with them. But I also believe people have been writing as we are progressing. You have to be fast at taking screenshots. So these are the trial questions. And then chapter 2 statics. So this is book 1 of physics with all the topics of senior 5. And then there is book 2 with the topics of senior 6. But the good thing, you are with SSA, you are with us, so you are safe. Maybe by chance at any one moment you will land on the book. Okay, so these are the final unit numbers that you're going to go with. You are the first people I've told you that don't want to leave class. More numbers, unit numbers. You see, people may think, do you know what it means to do unit numbers in your first lesson of physics? That means you have started your journey to passing. And I told you should take unit numbers serious because they can be turned into scenarios. So by the time they are turned into scenarios, that means you also be in position to attempt them. People have Tubies in soft copies, but I prefer you having your own. So the paper is paper 1 for mechanics, or for search, or for this topic, 1999, number 2B Roman 1. Also always create time. Go through the question bank, divide the question bank into topics. Set. See? Then the other one is UNEB 2016. You may even find that some questions overlap. Number 1A, Roman 2. One 2002. Number 2, a Roman 3. Yeah. Then also in Roman 2, you also do it. So you take that screenshot, yeah? And you're supposed to show it to friends. Take it because it's going to disappear. Take the screenshot because it's going to disappear. think we had issue with network. Yeah, issue with network. So I think we are done, as I said. So you're going to allow me sign out. Let me sign out from here today. So that means we shall meet again in topic 2 statics. I told you for kinematics, linear motion and free fall and projectile, you learn the mathematical physics from the math lessons on the drive. They will work for you. The rest of the things shall be definitions, which everyone understands. So allow me sign out as Dr. Paul, a tutor at Science Scholars Academy, Uganda, SSA. And that is my personal number. So hope you've gotten the assignments and hope the lesson has been a success to us all. Yeah, network has disturbed us at a wrong time when we are done. So shame upon it. Otherwise, thank you for attending. Bye. Look, I've been trying to read some messages. Thank you all for the messages. May God bless you too. And bye.